YouTube still says 248.
It still says what?
The YouTube.
Here we go. How's everybody doing tonight? Hopefully audio is coming in all right, and we got this set up correctly. We tried this earlier and everything was working great, so hopefully I didn't screw anything up.
So,
Hey Musaka, is the weather just as bad up there with you as it is with me here? It's gonna... You need chat a little bit bigger there, Reth. Alright.
I'm following along into.
Alright, hopefully the delay is not too bad. Alright, let me just do this. Alright. Yep. Alright, guys. So, the game plan for today, as the title and thumbnail and all the Discord posts suggest, is we have Reth here today with us, and this gentleman right here has been a huge help for me with understanding what the heck is going on with ShakeTune. Because I look at it and I just see a bunch of really colorful pictures and don't really understand much more past that. But yeah, real quick, Killer Prince, thanks for joining. Raven, good to see you. Brad, 3D Medic, welcome. Marcus, how you doing there? Is that Spitzburn? Welcome. And Mike, thanks again for your help earlier. Appreciate it. And Musaka. Yeah, that's a lot of rain, buddy. Pop away and Jose, welcome. Hey, are you anywhere near that river that flooded over in Westwood? We almost got an office space up there that had water stains about 6 inches up the wall. So we did not take that office space. What's up, DeBro? What's up, Dan? Shake weights are not going to be in this stream, but maybe in the follow-up. What's up? What's up, Havoc? What's that? Yeah, I was going to put shaking it with Reth in the thumbnail, but I didn't want any flags. You can't hear Reth? Uh-oh. Uh-oh. All right, let's try this then. All right, try now, Reth.
Can you hear me now? Can you hear me now? You can hear me though, right?
I can hear you. I can hear you. I just turned on the audio for you, but hopefully.
So, no one got my shake joke then, huh?
Can you guys hear Reth now?
So, and I don't know how to sign, so better
but quiet. I turned up Reth. I don't think Reth has ever been told that he's been quiet.
No, that's not a very common phrase. I've been told a lot of other things, but not that I'm quiet. Hear him, but faint. Is there a way to boost my volume in your OBS?
Yeah, I have it up. Try it. I turned it up even more. I don't want to turn it up too high, but I guess I might have to.
You guys, I can hold up. You can hold up. I can make it louder. I got no problem. Hold up signs. It's gonna take.
I don't want you to. I don't want you to be forced to talk loud. It's getting better. All right, we're just gonna crank it all the way to 11. All right, how's that?
You guys won't be able to read my writing either.
Now it's good.
Chicken scratch. All right, cool. Thanks, Masaka. Right.
Sweet. Hey, John, how you doing? All right, you know what? I might even. This is at max right now for you, so I don't know.
Is that max?
Can I turn?
Already better. Thanks, Brad.
There we go.
Yeah.
All right.
I could draw it out. Yeah, that might take a while too. I don't know if you guys can even read that.
We'll be here all night. All right, so you guys can hear him now.
So if you guys got questions, I mean, it's kind of, we were thinking audience participation. So if you guys got questions on things, just go ahead and post them, and we'll answer them. Try to answer them as they come along. You know. So
yeah,
we'll give
I was gonna say, and feel free to, like, if you guys are running tests on your printers, you know, you can post the graphs up in the Discord stream as well, the Discord channel as well. And if they're super different from my graphs, then maybe we can address those too.
Yeah, I got no problem with that. That's, I mean, I gotta find your stream now.
Okay, so now there's two Reths. I thought this was gonna happen. Okay, so what are we doing to eliminate that. All right. So let me see something real quick. Reth is not muted. We got Reth squared.
No. Thunder Keys, that's not happening. Spits.
At which point, after
I don't want to start answering questions if they can't hear me.
Still nothing? Like, you can't hear Reth at all?
Really?
I thought we just fixed this.
There we go.
All right,
there might be.
Do we have 0 Reths, 1 Reth, or 2 Reths?
How many Reths do we have?
How many Reths do we have? And does anybody have any tips on? Hold on a second. Oh wait, hold on a second. Is this a Teams thing? Like, we can hear him now. Okay, but how many of him?
Yeah, you get 1 of me or 2 of me.
A little echo. We got what? Do you remember what we did earlier to get rid of the echo?
I don't recall, Senator.
All right. Is the echo tolerable for you guys? What's up, Clown Hammer? 1.5, Papa. Dose. What the shit? Well, he's not talking now, Raven.
I'm not. Yeah, I can talk if it makes it
tolerable.
Seems good now.
Right.
Yeah, it's tolerable when I'm not talking. Thunder Keys.
All right. All right. So we'll start off with the GitHub for We'll start off with the GitHub for ShakeTune. All right. So I don't think we really need to go through installation of it because the installation's pretty straightforward. It's just one command, and then you add this junk.
You just need to add that ShakeTune in the brackets. You don't even need anything else.
Yeah.
Literally the first line of that is all you need.
Yeah. This is the part you need because the rest is all default. And then if you want if you want to change the default, that's when you uncomment something. Like, for example, when I was having that issue with the 600 test of it timing out, what was it? It was this one right here, the timeout. The timeout section. I uncommented that and extended that to 1200 so that it would be 20 minutes instead of 10 minutes.
Yeah. All right.
You get that booming voice of authority.
I mean, if you go on Forum Discord, you'll see that I have the commanding voice tag.
Oh yeah, it's a custom tag for you.
Yeah. I love you too, Thunder Keys. Miss you already.
Oh yeah, do you have more than one mic on, Reth?
No, I got one mic, camera. I mean, I can put the headphones on. If you think that would help.
I don't think that would help because you weren't using them earlier. But you have YouTube muted on your side.
Yes, muted.
Okay.
100%.
All right. Well, you guys just deal with it. You got double the dose of Reth. Okay. You got double the dose of Reth. That's consider yourself lucky. All right.
I don't know if my wife would agree with that.
What's up, Timor? What's up, Joe Russ?
So I think here we have different levels of knowledge on input shaper, right? In the audience.
Yep. So So I would assume I can lower the volume down a little bit. So. All right, here, let's do this.
Raven, you're making me laugh. You're making me laugh. So while you fiddle with it, I'll talk, and then we'll just see where it goes, right?
Yeah. Let me go over to the next tab for the documentation.
Yeah. Okay. We'll walk through the documentation. So what do we got there? Axis map calibration. You don't need to run it. It's in beta.
Okay.
It's basically trying to automatically figure out your ADXL orientation, and that's because Clipper allows for axis map to be a variable in the resonance. But as we'll explain later, it's not necessary. Clipper still knows what's going on.
Yeah, I don't think I've ever ran that one.
No, it doesn't. It's not 100% works all the time.
Yeah, I think I've used just about the rest of them. Let's see. Yeah, I've used the rest of them, but not axis map. I think I might have done it once just to see what it was doing. But yeah, Havoc brings up a good point too. He accidentally installed Clipane instead of ShakeTune, and I remember you dealing with that. So I think that's a good talking point to start out with. So Clipane is, and Reth, correct me if I'm wrong, but that is like a version, not like a version of Clipper, but like it's kind of like a is it like a organization for like configurations or whatever?
That's more of what it is. So
and if you already have configuration set up, when you install it, it's going to delete everything. So
but there is a command to uninstall it. Fricks put a command in there to uninstall it.
Now, when you uninstall it, does it bring back the stuff that? All right,
yeah, so Fricks did that, added that. I don't know how new that is because I've done that mistake once.
I did that mistake as well.
Yeah, and I just ended up reformatting and starting over.
Yeah, I did that as well on my Mercury. This was well over a year ago, I think.
But I think he has added a command. Because he backs up all your configs, and then if you want to uninstall it, I believe there's a command to bring back all your old configs.
Okay.
Because of this whole ShakeTune, Clipper or ShakeTune Clipane thing, that was people wanted the module because ShakeTune used to be a module in Clipane, so he bifurcated them.
Yeah. So I know if you're looking at the ShakeTune, just make sure whenever you go to install it, you're installing the one that says ShakeTune. If it doesn't say ShakeTune, don't install that one, unless you want to and you want to start over.
Yeah.
I mean,
you could use Clipane. Like a lot of people use Clipane, and it just makes for them. They like the organizational of the configs, the fact that everything's there. So some people really like it.
I haven't given it a shot. Maybe on my next build, I'll try it.
I haven't used it. I found it for my brain. It was too complicated. But other people find the organization perfect for them.
I think I do want to try Calico though. Thunder Keys is giving it a thumb down. I recommend
Calico.
Yeah. Thunder Keys is agreeing with the Clipane ShakeTune. All right. So I think one of the correct me if I'm wrong, but the compare belts is probably the best place to start.
So the way, yes, you would want to start with compare belts. And generally, it only tells you really one thing, and that's are your belts even?
Yep.
It doesn't tell you what the tension of the belts are. It doesn't. You can partially use it for mechanical, but not really. So really, it's just there. Are your belts even? So in your case, right, your belts are even in frequency and not in amplitude.
Right.
And I did. Go ahead.
And I was gonna say, and based off of our last conversation about this graph, the more important way to look at this is to make sure that the frequency is matched rather than the amplitude.
I mean, ideally, you want both.
Yeah.
Right, but most of us are dealing with printed parts. Right, there's tolerances. There are belt paths may not be 100% equal, even though we try. And then speaking and see if your mic is picking up his voice with your speakers. Echo's making this thing a little hard. Oh, Django, we were having such a fun time.
All right.
They think it might be your mic picking up the echo.
It might. I can try to lower my mic. Because I do have you coming through the speaker. So, all right, hold on a second. Let's see. Actually, you know what? Lower
you doing headphones? You doing headphones?
Like, I can still hear you coming through my speaker. I just turned the volume down on my speaker itself.
Yeah.
So, hold on a second. Maybe that'll help a little bit.
That help at all, guys? I know, Mike. I know.
Yeah,
that's friendly.
Yeah, we that's immediately where our minds went, Mike.
Yeah. My wife is telling me the feedback's horrible.
Oh yeah. What did we do last time, Mike? Do you remember what we did last time to fix the feedback?
Let me swap here. Let's see. All right, so we're gonna go headphones. See if that helps.
All right, how's the headphone? Is that any better, guys?
Any better for you?
Reth is gonna sing us a song to verify audio.
Any better for you? It did not help.
It did not help.
Oh, you're killing me, Smalls.
Let's see. Oh, let me see. What did we do earlier? What did we do earlier? God damn it! Why?
Got better? Is it better if I'm leaning forward and actually talking into the mic? Nope.
Has anybody used Teams with OBS before?
And worse. Not better than worse. Good God. I think we get. I got no suggestions, man. I think it's on your end.
Yeah, it's definitely on my end.
Because you're coming out clear to me, man.
Keep talking?
What? Want me to keep talking? I can keep talking. So, it's a beautiful day today. I'm in a beautiful office. Priceless paintings on the wall for my kids, as you can see. So any back feedback? Hey, Voron Widow, if you're listening, is it getting better? Pro streamer.
I feel attacked, Havoc. At least I didn't delete all my config files.
It's good now, whatever you changed.
I didn't change anything. Okay. I didn't change anything.
I don't know, man. Now it's back. It doesn't like my voice.
Yeah, no, Django, no change. I didn't change anything.
It's not. Is it a real bad echo? So, what if I talk quieter? God, half the stream's gonna be us trying to.
All right, so if I click this button and Reth talks, can you guys hear him?
Hear me? Want you to try?
You want me to try headphones? Oh, fine. All right.
Good God. I don't know, man. I don't know.
How about this? I'm enabling echo cancellation. Break out the cans. I have Dr. Pepper. So,
All right, what about now? Oh.
learn me real good. Echo is gone. Headphones for the win.
All right, so the echo's gone.
All right.
You guys can hear me
So-
fine, and you guys can hear Reth fine.
It appears to be. It appears to be. We have solved it with technology.
I broke it again.
Oh, I didn't do anything. I didn't do anything. Anywho, all good now. Thank you, Thunder Keys. You're really boosting my confidence. All right, so this graph, right? If you have to choose, you choose frequency over amplitude. Because the amplitude means something is damping or affecting that belt. So in your case here, there's something that is stopping, I think it's the B belt, no, A belt, from vibrating as high. But what's more important is that the belts are vibrating the same.
So
And that is why if you have to choose.
So would you say that at this point it's more in line with something about the way the printer is built versus the tension of the belt?
Yeah, it's some sort of, it's probably a mechanical issue. It could be that one of your XY joints or your motor mounts or some mechanical thing is off. It could be a bearing. Maybe a bearing's not running as smooth as the others. So something mechanical is probably doing it, but you may not be able to fix it.
Okay.
Right? You could spend days trying to diagnose it, and it's not worth it.
Which I have done. But I guess the important thing here is that the graphs are shaped similar.
Right. You want, so if you look, you got, so way Fricks does this is he tries to match like peaks. And that's why you have alphas, alpha 1 and 2, and betas, beta 1 and 2.
Yep.
And then, so that's, if you look on the right-hand side of that graph, you have like the flight path or the runway.
Yep.
Ideally, you want them all in green. But if you can't get them all in green, like it's showing, you want them all on one side. So if they're on one side, like your alphas are, what it means is the belts have the same frequency.
Okay.
If you got if you have alpha 1 on one side of the runway and alpha 2 on the other, your belts may have the same amplitude, may not, but they don't share the same resonant frequency.
So there's more investigation that needs to be taken.
Right. You could be something else going on, and then you would go to input shaper.
Okay.
Explain to you what power spectral density is. Just the amount of energy in that's so you're putting energy into it. So if we go to pulse only, like okay, so very top it says mode pulse only,
yep.
and then APH 75. So pulse only, there's two ways to do this. You can do a sweeping where you'll see your tool head actually move left to right.
Yep.
And it's vibrating the tool head as it's moving across. The APH is accelerations per hertz. That is actually how much energy you're putting into the system to excite it, right? So if you're doing just a regular pulse, it's just vibrating in place like this. How hard you're vibrating are your accelerations per hertz.
Now, is there any reason why we would change that?
Yes, there are reasons. We'll do that. We'll talk about the reasons when we get into input shaper. But there are reasons. But power spectral density is how much of the system is vibrating when you excite it at these different frequencies. And what it really does, it's just telling you kind of the value of that resonant vibration. So
Okay.
the value itself, shown on the left, isn't as important. So, if someone says, "Oh, but I got 1 e to the 5," and someone else says, "Well, I got 1 e to the 8," it doesn't really matter, right? Because it's relative to your system. Do you know what I mean? It's
Yep.
you're not comparing apples to apples here.
Yep. Havoc, I'll show you in a second, okay? Just want to cover this graph real quick. But
So
yeah.
then, do not use the estimated similarity. That is only really helpful if your graphs. So what estimated similarity is how much does one graph, if I put the other graph on top of it, how similar are they, right?
Mm-hmm.
But you could have the worst graph in the world. So long as the other belt matches it, you're going to get a high similarity. So for your graph, you could actually kind of use it, say, okay, well, these are not, you can visually see that the graphs are on top of each other.
Yep.
So the similarity, okay, fine. But in all reality, it's really the what the picture of the graph looks like than that number. That number effectively is meaningless.
Yeah, I always just kind of, just like the experimental, the excellent mechanical health, I always just take that as, not really like gospel, but more of like a, hey, you're on the right path. Like, I guess you could say.
I mean, I would personally, I would even see that as being too much.
Just ignore it altogether.
Yeah, just ignore it.
All right. Real quick, Eric, thank you very much for becoming a member. And Havoc, let me show you. So if you're on your dashboard, right, you just ran your ShakeTune test. What you're gonna want to do is you're gonna go over to your machine tab, and this is with mainsail. It's gonna be a little bit different with fluid, if you're running fluid. And then you're gonna look for your ShakeTune results folder. Click on that, and you will have your vibrations, input shaper, belts, axis map, and static frequency. These two will likely be empty because you won't really run those. Actually, I don't even know what static frequency is, but
we'll get to that test.
Okay.
That's actually another test.
Okay. And then so your belts graphs will show up here in belts, and depending on your choice of how many you keep, that will show you how much, and you can just set it up so that your newest comes up on the top. So, but yeah, this just goes to show like how many times I test my belts. Okay, so May 1st I kind of went a little wild and did a whole bunch, but I think that was also when I reinstalled the gantry. So when I went and reinstalled the gantry is when I ran multiple tests. As you can see, like it started off where they weren't as close, and then I kind of inched my way to getting the best possible graphs. And this was all done by
They keep running this. Oh, go back to your last graph you showed.
This one?
Yeah. So this is a good example of why that similarity number, like you get 97.2% similar.
Yeah.
Right. But the very first graph we looked at was actually better.
Yep, it was. Yeah.
And so this is kind of a reason, why you shouldn't be using that number.
And it's funny too, because it says estimated similarity 97.2, but then it says good mechanical health versus the 95 and excellent. So
right.
That's right, Mike. If you learn anything, and that doesn't just go from my channel. I'll just show some love to Reth too. He's got his own channel as well. So,
I don't give enough content as you do.
Yeah, it's okay. I can still show you the love. And so don't expect to run one belt test and call it. So
and small adjustments.
Yeah.
So like let's say he got this graph, whatever graph you pull up, just pull something up, doesn't matter.
I'll pull the last one up.
Yeah. So say he wants to adjust this. We're not talking half turns at this point.
No.
We're talking like eighth of a turn of a screw, a 16th, small adjustments. But at this point, I would say this graph is good enough, right?
I have not touched, so I'll probably run it again just because I have run a couple speedboat tests. So I have no doubt in my mind that it is shaking my machine up a bit. So I mean, we can run one now. These ones don't take too long to run.
Yeah, they don't take too long, and you can continue. So what's nice about the way ShakeTune does it is he's going to run a test, but we can go back and continue talking about the other graphs because you can just let this thing do its thing while you're looking at everything else.
Yep.
Because it saves it in main cell.
So we looked at the graph, and then is there any specific documentation in here for the?
There's documentation galore on this stuff. Like Fricks has done a really good job on documenting a lot of the big things, giving some examples. So not so much in belts, but more input shaper. What you're also going to see. Go ahead.
I was gonna say, so this is what you were talking about before with the landing strip.
Right.
Like this would be like strip. in the best case scenario where you have your belts right here along this red dotted line. So if you get your belts to show this or on the red dotted line, call it good.
Right.
You're good to go on there. Even you see the two humps over here. That's okay. The graphs are lined up. You're good to go.
Yeah, and ideally, so all graphs, all your belt shapers and your input shapers, ideally, they should have a single peak.
Yes.
Belt shapers, you're gonna have two peaks. You're just gonna. That's effectively what you're looking at right there is your XY joint. Right, that's where your belts are coupled together in the XY joints, and the two peaks is caused by that. Very rarely do you see a single peak.
Yep. Give me 1 second. Look something up on my end.
So, yeah, this test, you can run this. We might as well get into a negative of running any of these ShakeTune tests, any of them, is the potential to knock something loose. Effectively unscrewing something. What about a double rainbow? Okay, so one of the reasons why you don't want to mess with that or raise your accelerations per hertz too high is you're adding a lot more energy to the system. And yeah, you're going to get a cleaner graph, but you will also start diminishing potentially problemsome peaks. So you'll effectively hide potential mechanical issues.
Okay.
On top of that, if you go too high, you could start loosening screws, and over time, screws can literally fall out.
Yeah, that doesn't sound like fun. All right, so going back to my graph, right? So we talked briefly about the pulse only. When you're running this, is there I mean, there's got to be a benefit to running sweeping. There's also got to be a benefit to running pulse. I know, he just didn't add sweeping just to add it. So, do you know the difference between the two and like how the differences between the two may help with understanding your system?
Yeah, so sweeping, we did a bunch of tests when sweeping first came out. Fricks, and I think some others, we ran tests on it. And sweeping was really created for systems that aren't as structurally sound. right?
Okay.
So Voron, I think your print, I forget the name of your
It's
printers.
the Ender NG. The
Ender NG, right?
Yep.
They're fairly fixed. They're pretty strong. So we're talking more like bed slingers that aren't
Okay.
put together well. You know, printers that just you can tell they're not as stable. So there's and they could never get anything really coming in on Input Shaper at all, even standard Clipper Input Shaper. So they created this sweeping to be able to kind of hide or mask some of the structural issues in the printer itself. For us, or if you have a pretty strong printer, frame-wise, you know, we're structurally strong, it seems to add an offset to things, very similar to what the LIS 2DW does, but in a different way.
Okay.
And it'll create some peaks that aren't really there, and that's from its moving in its motion system, or it's usually it's going to be in the x-axis. So it's not really recommended for a Core XY, or at least a Voron, which is what I've tested on Core XYs. You get better, cleaner data just continuing to use Pulse.
Take care, Mike. Thanks for helping out earlier. So I've heard, well, not heard, but I've seen someone mention it before, and I'm not going to drop any names because I forgot who it was, but also I wouldn't do that anyways. But I believe it was like the general general like statement about the sweeping was that it gives a more accurate representation of what your input shaper and belt graphs look like during printing, because the print head's moving and stuff like that. Is there any truth to that, or is that just maybe like a slightly inaccurate understanding of what's going on? Or
it was something that I was hoping it would do, kind of almost like a dynamic input shaper.
Yeah.
But it doesn't necessarily do that job. I was really hoping, like, oh great, now we can get the dynamic, we can get what's actually happening when it's moving, but it ends up distorting the data.
Sure.
And
too many things going on at once.
Right, and for me, what I use Input Shaper for, really, and to help people, is mechanical issues in their printer.
Yeah.
Right. So you can really use Input Shaper to diagnose, mechanical issues. And so it was adding a lot of noise to that, which is making it more difficult to figure out what was going on.
Yeah, I can see that.
And plus, Clipper itself doesn't have a mechanism to handle dynamic Input Shaper. Right, it's a static measurement that Clipper can cancel out. It's a static measurement, and generally it wants a single peak. It can handle multiple peaks if you use the humps, the 2-hump EI, 3-hump EI, but this is a horrible graph. But
hey, it's all in the green.
Deal with the dynamic.
It's all in the green.
It's all in the green. It's all in the green.
But yeah, so
it's probably go ahead.
No, I was gonna say, so this is I think this is a good graph to look at too. This was after a couple tests of really some hard printing with this printer, and I think I did recently. I think I did about 6 speed bounce on this, and then I used kind of those settings. I also printed. I tried to print this like functional item out of it, and it survived. You can kind of see a lot of artifacts in it, because obviously I wasn't printing it at the recommended accelerations and speeds, but this was like a 4 to 5 hour print that I just did in 2 hours. So, but that took a toll on the printer. So now I have to go back. I think the belt tension's probably fine. I just probably need to go and double check some screws to see if they came loose in the motion path. I mean, unless you think this is a belt tension.
It could be, right? Like that's why this doesn't really tell you what's going on.
Yep.
Right? It just tells you, are your belts tensioned the same? And they kind of look like they are, but I mean, it could be a mechanical issue. So if you see something like this, you're running Input Shaper to figure it out.
Okay.
And to see what's going on. It could be the fact that, after you ran it, something got a little loose, belt stretched a little bit, screws, moved a little bit and fell into a nicer place.
So I'm assuming when you're going and you're comparing the graphs that you want to use the graphs together. So basically,
yeah, they work together.
So you take a look at this and you say, all right, well, something's obviously up. So let's go run Input Shaper and see if there's any abnormalities with that graph and where on that graph it is. Like, I'm assuming we would expect to see something around, what, 60 hertz? Like, is that, because that's where that second peak is over by the beta.
Well, actually, it's just your alpha peaks here that are a problem.
The alpha peaks is the problem?
Yeah, at 100 hertz. But this would be a good area because we had the good graphs.
Mm-hmm.
This would be a good time to use the power spectral density. So you could compare this power spectral density to your good graphs power spectral density and see, okay, where are they at? Like, this was like 2e to the 6. Now you're at 4e to the 6. So I suspect that something came loose.
Okay.
Like just comparing these, like a 2.5e to the 6.
Yep.
I suspect that what happened was you ran this for a period of time and your belts, your machine's moving in X and Y and diagonals and everywhere, that it's pulling on the front idlers and it potentially pulled a little bit more, and now you need to retighten them a bit.
Okay.
That's what I suspect is happening.
So it might have lost a little bit of belt tension.
Yeah, and that's common that you'll see, right?
Yep.
Like, we tension it, and then you run something, and then you got to go tension it, fine tune it. It's common.
Yeah, and I mean, this isn't something that you're gonna have to do after, half a dozen prints. But if you're pushing the machine hard, this is something that you're gonna have to think about.
Right, and it's not just pushing it like an X and Y, right? You're dragging that tool head all around.
Yeah. Yeah.
So generally when I do belts, right, before I run this test, I'll make the belt adjustment. And what you want to do after you make a belt adjustment is to, if you have say you have a Voron V2,
mm-hmm.
you want to home and QGL and home Z. And the reason you're doing that is not because you've lost home, the home position, is that you want to cycle those belts around. And you want to kind of readjust where all the tension's at. For Tridents, it would be a Z tilt.
Yep.
And so that kind of helps get rid of potentially some of this, and you'll see your belts, they'll be stretched in that home Z or QGL or whatever routine your printer has.
Okay. And so I think not really sure if there's anything else really to touch on the belts.
No, there's not much to touch on the belts.
But I think probably one of the biggest questions that people are going to have is going to be with the Input Shaper graphs. That seems to be the most common place for questions. So let me go over, and while we're looking at my old graphs, I'm just going to run new Input Shapers to match the new belt. So,
sure. So while you're doing that, so what Input Shaper is it what it does is it uses the values that you get from Input Shaper, and then Clipper then will inject them into the motion algorithm it has to determine the where the tool head's going to go. So it figures out, when you run your G code, Clipper figures out, okay, he wants to go at y equals 0, x equal to 50. And it figures out like a time plot, right? It's figuring out, okay, this is how much I have to accelerate, and this is the constant velocity, and this is what I need to decelerate. So what Clipper does is based on the values you put it for input shaper, it's got a bunch of math behind it, iterative solvers and stuff like that, and it will figure out how it needs to adjust the acceleration and the velocities and the time it takes to get to where it needs to go. And it does this by inputting pulses into its calculated path. I'm making this real simple, but so
I'm understanding it. So
right. So for example, 2 hump and 3 hump will put in like 5 pulse. 3 hump will put like 5 pulses in.
Okay.
For changing your acceleration. It's going to put a pulse in at different times while it's moving, right? And then the motor sees this pulse and will adjust accordingly. And that's how it can reduce the ringing or the overshoot on a tool head by basically putting different pulses in to slow it down or speed it up or whatever it needs to do. So each of these, like ZV, so we'll just go over the shapers, right? So standard Clipper has these 5 shapers. And MZV was created by the Clipper guys just for Clipper. That's not really if you want, industry standard shaper. And rather, instead of MZV, what's out there is called ZZV.
Okay.
But what they found when they were first doing this was that ZVD was too close to ZV and didn't provide enough cancellation of your resonance frequency. So then they made a modified shaper and it became MZV. So ZV is a well-known input shaper for us. It's way too narrow. And you can see that. So if you go in your graph and you look at all those dashed lines behind.
Yep.
You got a little pointer so people can follow.
So
like let's start that top one, right? That blue one right there. That's your ZV graph, and you can see if you follow its shape, it goes real down like that and then back up. That's all that's canceling is the narrow peak. That's it. So then the green one.
So this one, you're talking about this one right here.
Yeah, that one. That's the narrowest shaper. It's not recommended to use that because simply by a dynamic motion of your printer, you're going to fall out of that.
Yeah.
But it does give you the fastest acceleration, but it's kind of a misnomer because you're going to get the highest acceleration, but chances are you're going to fall out of that shaper while you're actually using the printer, that you're still going to get ringing.
Yeah.
And you can see
and you want to use the lowest of the max acceleration. So for example, with my y axis is lower is a lower number than x. So we're not going to want to exceed the max for y.
Correct. Now because some people use it, Calico allows you to put in a max X and Y. I've had some luck. I can't say that it's worth it.
Okay.
To be honest with you, and that's because nothing else supports it.
Sure.
Right. All of your slicers don't support independent X and Y accelerations, so it's fun to use, fun to test with, but I wouldn't say like if you actually want to get good prints to use it.
Yeah.
And I'm sure some people will say, "Oh, we get great prints." Some may.
Yeah, probably do. Yeah.
Probably do.
Yeah. I mean, it's not going to be universal, but yeah, it might. No. For you, it works. And that's awesome that it does. But it's the exception, not the rule.
Killer Prince, you got a question?
So Havoc has a question. What order do you run the test in?
You always start with belt shaper.
That's exactly what to say. So, get your belts looking good, and then at least the way I do it, and I might learn something right now. When I do it, I run my belts until I'm satisfied with how my belt graphs look, and then I'll move on to input shaper, and I'll run that, and I'll verify that everything's looking good. I'm aiming for that single peak. I don't really care so much about the numbers that are on the side, the max acceleration. It's more along the lines of like the shape of the graph for me.
You should care about the max acceleration.
Well, what I mean is like, I'm not looking for like the highest numbers. Like I'm not.
No.
Like I know what my systems should be around, and like looking at this graph, my number should be in the 20s and 30s. So, that's what I expect. I'm not like if I run input shaper and I see max acceleration is 70,000. First of all, I'm gonna be very surprised, but I'm also gonna think that something's wrong. Because
also if you have a really low acceleration.
Yeah, and then on the other end, if it said MZV, 2000 acceleration, then I'd be like, yep, something's definitely wrong.
Something's wrong. So accelerations. I mean, let's just talk about this legend, right? And then, so Killer Prince, and we'll get to that, man. Your question of how to secure the cannon to the tool head.
That's a good question.
Get to that. But just to give a kind of overview on this thing. So the way this works is your most aggressive shaper is on the bottom. So 3 hump is the most aggressive. It's going to try and cancel out the most frequencies. ZV is the least aggressive because it's only canceling out that peak, the single peak. The frequency is the center point, not of the graph itself, but the center point for that shaper. So I see people trying to mix EI shaper with MZV frequency. It's not going to work. It doesn't work that. So you really need to use the frequency given by the shaper you're using.
So you've seen people use the EI shaper with MZV frequency?
Yeah, and you've just thrown it, and then they still wonder why there's noise or why there's ghosting. It doesn't work that.
Did they? You have did they give a reason as to why they were trying? Like,
yeah, because they thought the frequency with that would be better. Like it's a lack of understanding of how these. Okay. These are all math equations, right?
Oh yeah.
And they're very specific to. The math works out when you follow kind of the steps. The vibration it's an estimated residual vibration percentage after you've applied the shaper. Now, here's where ShakeTune diverges from standard Clipper.
I wish I had a standard Clipper graph to show, but I don't.
And Calico.
Yeah.
Standard Clipper doesn't take. So, let me back up. ShakeTune calculates a damping ratio. As you see, there's an estimated damping ratio.
Yep.
It actually calculates that from the data, from that graph. And you can think of it as the width of that graph. Right? So 0.5059 is the width of that graph. It's a valueless number.
Okay.
Right? So it has no units. I'm sorry, it's a unitless number.
Okay. So
what it does is it takes that value, the ShakeTune puts that value in, actually uses it. Whereas Clipper, default Clipper or default Calico, they use 0.1 as kind of a general catch-all value. They don't actually calculate the damping ratio.
Yeah, I have heard that.
Yeah, and the effect comes in when you're talking vibrations. So everything from vibrations to smoothing to max accel, all those columns use damping ratio in their calculation. Which is why in ShakeTune, you will never see let me say, the current version of ShakeTune, you will never see MZV show up with 0 vibrations. It will always have a number. Now, is that number, Fricks, after many conversations with Fricks says, look, if it's less than 5%, go ahead and use it. I'm a 0% kind of guy, so I'll always use EI because it's 0%.
Okay.
But you could use MZV in the situation, but if your print shows some sort of vibration, you're going to want to drop down to EI.
Okay. Hey there, Wick Central.
Hey. Smoothing is basically how much smoothing it's adding to the print. And some place you would see this would be in a benchy. In the back of the benchy, the lettering on the back of the boat, right? If you got a lot of smoothing, that just goes away. You don't see any lettering at all. So what it is your more aggressive shapers, like your 3 humps, your 2 humps, will add more smoothing, and that's that number, that 0.025 for ZV all the way down to 0.039 for 3 hump. So the more aggressive your shaper, the more smoothing is going to be. Now, input shaper in ShakeTune will allow you to set a max smoothing. So let's say you got something that needs really, really fine detail. You can set whatever smoothing value you want, but it has repercussions because that value then will get sent to vibrations. It will also get sent to max accel. So your accelerations may come down. Your vibrations are going to go up, but you're going to get no smoothing, right? You could set it for 0 if you want. Your number is going to be all messed up, but you could do it. So that's the smoothing. And the max accel is a recommended max accel saying, look, if you use this shaper, do not go past this accel because we can't really guarantee that it's going to work. Now, you can go past that, but there's no guarantee.
So real quick, touching on the smoothing. Oh my God. So is that's not this smoothing right here, right? Where is it? That is not.
You're talking pressure advanced smooth time.
That's not smooth time.
No.
Okay.
Pressure advanced smooth time. Something else.
I just wanted to make sure that there was no confusing this smooth time in the smooth time on the input shaper graph. I just wanted to make sure that was mentioned.
Two different things.
Yeah. So I just want. Let's go into the graph. Oh wait, yeah. Let's go to the graph that I just took now. So this graph
is showing stuff, right?
Yeah. So this is the current graph, and this is to go along with that current. Oh man, the glasses came off.
Yeah, well, every now and then. So this is another. If you go on the top right, you'll see your square corner velocity.
Top right. Yep.
ShakeTune allows you to set. I believe standard Clipper may too, but ShakeTune allows you to set a square corner velocity that you want. Standard is 5 millimeters per second, and what square corner velocity is, just so we're all clear, it's what is the speed that you're going to take a turn that's greater than 90 degrees. 90 degrees or greater, right? So 5 millimeters per second is usually the standard. If you're going to take a turn that's greater than 90 degrees at 5 millimeters per second. When you raise square corner velocity up, what happens is that your max accel will go down. So like if you ran this with a 100 square corner velocity, your max accels may be 0.
Okay.
It's like you can't do it.
Yeah, don't do that.
Right. 20 is a bit fast.
Did I set that?
Yes. You either set that in printer config, or you sent that in the test.
All right, let me go look in the config real quick.
But, if it prints at 20, then you're good to go. For people that ask, when they come on Voron Discord and they go into the residence channel and they ask for help, the first thing we have them do is reset that back to 5.
So I don't...
Just to get a baseline on it. It should be in printer.cfg.
Yeah, it won't be in here. Yeah, I just checked my printer.cfg. So
it'll be like max Z velocity. You've got it set somewhere. I don't know where. It should be, usually it's right there, or it's going to be in extruder section. No.
I'm gonna have people over here looking at my config, and they're gonna be like, "Oh, that's such an ugly config." Oh,
It's nicer than mine. There's not comments everywhere. I forget what things are, man. I got the thing commented up. Be like, oh, this is what this does.
that was mostly a jab at past streams.
But yeah, no. So square corner velocity will have an effect, a direct effect on the recommended max excel. But your max
that could be changed here.
Right
So I can just put 5 in there and run it again.
Yeah.
No, but that's not going to change the shape of my graph.
No. The shape of your graph is what it is. It's using the calculations.
Okay. But now my acceleration values will be different.
They should be. Yeah, we can compare it. If you run it, we'll compare it.
So.
Right. So
I'm willing to bet I got something loose going on.
Yeah. Like, what's the graph before this? I mean, we can do some comparisons.
So this is X.
Is this all-wheel drive?
No, this is also running the this is for this is the so this is the X
so
before.
Your standard frequency then is around what? 195, 85?
Yeah.
Yeah.
It's telling me MZV 87.
Right, you could use MZV. I mean, your residual vibration is 0.7.
Yeah.
So I'd try it out. I just like 0. I like the number 0.
Yeah, I do too.
Let's talk about the rest of this. Okay, so all of these dashed lines are different shapers, and the dip, you can see what it's going to cancel out. So you can kind of see how it's doing its cancellations. And the very bottom one on the, God, it's like right above the green.
Right here?
Yeah, there's like 2 there, right? Those are your humps. And you can see they're kind of like bandpass filters.
Yeah, you can see one, it's kind of faint right here.
Right.
And then there's another one that's like right above it.
Those are your humps. Your 2 hump and 3 hump. And basically what they're doing is canceling a wide swath of vibrations, but that's also why they have the most smoothing and the lowest acceleration. And then above that you'll have EI and MZV, and you can see they're both very similar, but EI will cancel out if you look at where the troughs are in the graphs. EI will cancel out a slightly larger range of frequencies than MZV, and so they play well. You know that's why they're both getting this fixing the graph. The teal line, I think it is the residual vibration. It'll tell you the legend on the top left.
So real quick, Spitz does bring up a good point. Do you want mouse control?
No, you're doing fine. You're following
sure?
along. If people, so this is the thing, right? Like when I'm helping people, I don't have control over anything there, right?
Yep.
So it's if I'm talking too fast and you need me to slow down, let me know.
Yeah.
Or chat, let me know. Yeah, don't let me open Paint. That's right, Spitz. If I've helped you at some point, you know I got my MS Paint or my finger.
I've seen it in your videos. I've seen it in your videos.
Yeah. So if you need to slow down, if I need to slow down, let me know.
That goes for you guys too in chat. Like if this is going too quick, if there's something that we just glossed over, or if there's something that we went over that you just didn't fully understand, just say something. Okay? No one's gonna judge you. I mean,
no problem there.
I mean, I must have called this guy dozens of times now, for the same question, but you know,
and one of the reasons I don't mind doing this is because it's not that intuitive to understand.
And it's not easy to understand. It's not something that you're thinking about on a daily basis. So like it's just not, it's not like I'm trying to think of something that you do every day that it's not second nature to you. So it's like
No. And there's not a lot of references on this. Like the reason I created started doing videos is because the only real good videos out there were by Eddie the Engineer and 3D printers and a whiteboard.
Yep.
Right.
Yep.
Like I was reading some stuff on Clippers, but it's like, okay, well, what does this mean? What does this graph mean?
And you can only understand so much by reading all those documents. And can you start over after I run and grab some cold snacks?
If my wife will tell you yes, I'll just keep talking. So we can start over.
And just so everybody knows, like this stream will be saved to the channel, so you're more than welcome to go back and check it out. But honestly, if I'm speaking from experience for myself, I'll probably repeat myself a few times. So we'll probably cover something we've already covered.
I repeat myself also.
So. Yeah. So you're bound to get your wish there.
Yeah. So, I used to work in the semiconductor industry. I worked for a company called ASML, and they're the people doing EUV, pushing to print as small lines as possible on a microchip using photolithography, steppers, and scanners. And I mean, these are multi-million dollar. I think the newest one's like $150 million plus.
Wow.
I was working on $10 million equipment, and they would actually run input shaping. Well, they wouldn't run input shaping, but they would resonant test their machines. They had it built in. They had an ADX accelerometer and everything. And they're also a billion-dollar company. But from working there, I realized that these graphs could actually tell you something because they had that machine characterized. If you saw a graph and they said, well, if the graph looks like this, these are the 3 things you need to look at.
Yeah.
And so I knew that there was something here. I just couldn't really find, besides 3D printers and a whiteboard and Eddie the Engineer, there really wasn't anything good. And trying to figure this stuff out, I figured, what, let's just make some videos on it and try to help other people to figure this out too.
And that's why I wanted to do this stream in particular. Just to get the information out there more. I feel like it's a real gray area in 3D printing, and it's a super handy tool to get your machine set up the best way possible. So
right, but it's also machine specific.
Yeah. So that's another thing, and that's a good point too. Is like you can compare input shaper graphs all day long with other people, but it's not really proving anything because it's just like your machine. It's not like unless you're comparing that graph to an older graph of you from your machine.
And adding the fact that all of our machines, or at least my machines, are all DIY.
Yeah.
Right. They're not.
Yeah.
Like if you were making bamboos, you would and it's coming off an assembly line. You would expect within a variance that all of their graphs would look exactly the same.
Okay.
But if you have all these self-source, all these pre-built, all these DIY printers, we're going to have similarities.
Yep.
But we're not going to be the same. And then you throw in different motion systems, right?
Yeah.
So most of my knowledge comes from Core XY. The Switchwire Core XZ, completely different graphs.
Yep.
Right? Similar, very similar, but like the Y graph is different.
Right. Because you have the bed moving.
The bed moves, yep. Right? If you change your gantry, right? So monolith gantries, very similar, but you adding those 2 extra motors all-wheel drive changes this too.
Yep.
And then you add different tool heads will change characteristics. So I try to do is try to like figure out what's common between all kind of Core XY, and then say, okay, this is what yours should look like. So we kind of know what a standard Voron build would look like, plus or minus, certain aspects. And that gets into a discussion of, ADXL placement, right?
Yeah.
Where's the best place to measure?
Yep.
And you get this nozzle versus tool head, board versus some center of mass, center of gravity.
So mine right now is placed right on the front of the tool head. So
Another place.
It's literally what I did is so my hot end fan is a 3010 fan, and it just so happens that the bolt spacing on the 3010 fan lines up really well with the KUSBA. So I just threaded the bolts right through that and just bolted it right to the front. Is that the best space, the best spot for it? Maybe not. But but it works and it's secure. The sensor doesn't move, and I run it with the hot end off, so the fan's not spinning. So that you're not getting any artifacts from that.
You can tell a spinning fan 100% on these graphs.
Yeah.
100%. You're gonna get a spike. Your time frequency spectrogram's gonna have a huge orange spike on it.
Yep.
And you potentially could see something in about the 125, 150 hertz range, showing that there's a fan there. You can also see a bad fan. Your fan could be off, but you could have a broken fin, or your fin could be chipped. It will show up with a bright orange spectrum on the spectrogram. But I like going back to the ADXL placement. The reason I have people always use either the standard Voron spot or most likely the tool head board, whether it's the Hart K style 2-piece or the EBB 36, is because each location of the ADXL, different locations, they will present the data differently because they're experiencing the vibrations differently.
Right.
So if you have first off, the ADXL itself is oriented differently, so you're going to get your XYZs are going to be different. But a tool head nozzle, the reason I don't like the tool head nozzle as trying to find mechanical issues is because the nozzle itself is a pendulum.
Right. Yep.
So
I personally don't do nozzle. I don't mount to the nozzle. So I either have it right on the front of my tool head. It's either on the tool head board, so like on the SV08 or my Mercury that runs the EBB 36. That's on the tool head board. So I just run those. But like for example, on my green NG, become on the front of the tool head because the USB cable gets in the way of the cutter. So it's basically mounted on a backpack, which, in my opinion, might actually even be a better spot than on the front because it's closer to the center. And at least in my thought process is, if it's closer to the center, then it might be the best for showing issues with the system, since it's, like you said, it's not on a pendulum like on the nozzle. But it's also not sticking out, at like the farthest reach of the tool head. So it's kind of smack dab in the center.
Right. And it all depends on, I haven't seen any good data from anyone that's basically kind of said, okay, we have figured out what these vibrations mean in these different locations. Right, like I did all the time. I did put that ADXL all over my Trident, and trying to figure out where is the best. What vibrations am I measuring everywhere? And I haven't seen anything similar. So like when people have this discussion, the ADXL on the nozzle is the best place to put it because that's where you're printing. Okay, but how do you know if you have a mechanical issue?
Sure. Yeah.
Right, like that's what I'm looking for. Because
That,
that's what people want help with, right?
Yep.
So, oh yeah, I died.
But placement is important on something like the switch wire when you're looking at the Y graphs.
You get different results.
So
placement, ADXL placement anywhere, you're going to get different results.
Yep.
Because the ADXL is seeing different vibrations based upon where it's at. Cartographers and beacons, they are not necessarily the best to use ADXL wise, and that's because generally you have a board with a coil and then a daughter board sticking up with your the wiring and the circuitry. That board, it can vibrate, right? And that's where the ADXL is on that board. So you can get signals that aren't there.
Okay.
That aren't, like if you compare that versus an EBB36, you could potentially, not everyone, right? It's not, all this stuff is not everyone is going to get the same result.
Sure.
But you see it, I see it enough on mine.
Yeah.
Where else
speaking of ADXLs, I just want to throw this out there because I do use it a lot and I really do like it. The KUSBA, the KUSBA, by
ShakeTune.
Yeah, I'm glad you said it because I was gonna say something completely different.
Yeah, we had a discussion of his name at Rocky Mountain.
Yeah,
it's
Ishik Tech.
Yeah, no, I would keep saying Isaac, but it's not.
That's right. I was gonna say Isaac Tech, but Ishik Tech. I highly recommend that board. It's very easy to set up, and it's fairly inexpensive. So,
I like the Boxy Probe by Provoke 3D.
Yep. Yeah, I remember we talked about.
It's also very small.
I remember we talked about. We did talk about that before. I don't know why I never bought it, but probably because I was scared to set it up. But
Wiki Central has a question here.
Wiki Central.
Yeah. So what I would do, his question is, he runs a beacon and he's got a Nighthawk 36 on a Micron.
Yep.
Would it be better to use the Nighthawk 36 instead of the beacon? I would measure both. And then look and see which one do you think is... So the question becomes, which one do you think is telling you the truth, a quote unquote, right? So one may look better from its perspective, but the other one is actually showing mechanical issues.
Yeah.
And so it's hard to say, but whatever you choose, you need to stick with it. You need to do all of your diagnostics
with the same one.
With the same one.
Yeah.
You can't keep switching back and forth because you're going to send yourself in a spiral.
I think another factor too is with a Nighthawk is how solid is the mount for it.
It's the same as an EBB 36.
No. I mean like on that particular printer. So like I've seen some mounts where, you know, they might not be the most sturdy, like the design of it, like there might not be enough meat on it to
yeah, or your umbilical on that version of your CAN bus backing board, your EBB 36 backing may be too heavy,
or you don't have the strain relief on there, which shame on you.
Well, some people will do the strain relief on the side, others on top. Like you start. So one of the things is, it's the cables themselves. I mean, I would use the Nighthawk 36.
Same. Yep.
I would use that.
Do you want to address the comment from Spitz? Brad, audio keeps cutting out for who? For me or Reth? And is anybody else experiencing that?
More audio issues.
This is a staple in my streams, Reth. So it's not you. It's 100% my channel.
But okay, so while we're waiting for people to respond, so the LIS2W on paper.
Questions are posted in Discord. Thanks, Dan.
Oh, let me take a look there. So on paper, the LIS2DW looks like a better device on paper. In practice, what they have is a built-in 200 megahertz bandwidth filter. Why is that important, right? Well, the 8XL has a 1600 megahertz bandwidth. What it does is it cuts off a lot of the resonant frequencies we need to recreate the graph. Like, this graph is not built just on signals from 0 to 200. This graph is built from signals from 0 to 1600. And it populates. You get all the resonant frequencies and everything like that. When you put in that LIS2DW bandwidth filter, you start getting a light show. So you see these on the spectrogram, you're going from 0 and it's doing the angles like this.
Yep.
The LIS2W, because of it, you'll get angles going the other way. So you get like this disco light show, right? You have disco parties. On top of that, so that's not necessarily bad. But on top of that, it adds an offset to the graphs. So that's that you can't determine what the real part of the signal is and what is the offset.
Okay.
It especially does it in the lower frequencies, where lower frequencies from about 0 to, say, 25 hertz especially, indicate binding. So something's not binding, or something's not moving freely, it's binding.
Okay,
so,
which could be improper belt routing.
It could be that, it could be unvorons, it could be your XY joint tooth idlers are too tight.
Yep.
It could be that you're riding a flange on a bearing.
Yep. Or if you watched, what was it, Steve Builds and there's a Grant from 3D Musketeers when he routed his belt around the plastic part.
Right.
Yeah.
It could be that.
Yeah.
So.
Not to call Grant out or anything like that, but I did find that very comical.
Well, that's very common, right?
Post them up, Thomas. We'll take a look at them.
Yeah, I gotta find your thing so I can see the questions people are asking. There it is.
Yep. So there's a question in there about explaining power spectral density.
We did that. The ZVD shaper. So Clippard comments that out because it's gonna be between ZV and MZV, and it's a little too narrow for our purposes. And what they found when they did the original testing on all these shapers, because these shapers, besides MZV, are effectively industry standards.
Mm-hmm.
Right? Like if you're moving a crane, you're using one of these shapers to get an exact position. A lot of motion systems, a lot of robots, they're all using, like, these shapers aren't 3D printer specific. And what they found for our purposes was ZVD was too close. You probably have a loose screw. Was too close to ZV in that it didn't actually help. Yeah, you probably got a loose screw.
Yeah, I think I know I think I know exactly where it is too.
If you go back to the Y, so this is a good example.
Yeah.
Go back to your Y.
I'll go back to the Y.
See this area right here where the secondary peak on it
Up top, or this one right here?
There. That generally is a loose screw.
Okay.
Generally, not always, but generally, it could also be your if you don't have filament in your extruder, it could be that hob gear or that freewheeling extruder gear vibrating.
No, but that would be for direct drive.
That would be for direct drive.
Okay. Because the
direct drive extruder.
Because this is a Bowden setup.
Yeah, so you probably got a loose screw in the tool head somewhere.
Okay.
But if you look, EI doesn't care. EI will cancel that out.
Yep. And then I think this actually could be a good segue to the other tool, the Excite Access. Yeah. And so we can take a look at this and we can see that this peak is right around what, 60, 63, 64.
55, 60, 65. I would say about 62 or 63.
So we can go and
So that tool, what it does is it excites hertz below. So you put a frequency in it, and it will excite a frequency below and a frequency above. So if you get 63, put 63 in, it will do 62.
okay.
And it will also do 64.
Okay. So and then you just run that for like 45 seconds, and while you're poking around, poking on your printer and seeing if you can hear that, and or maybe even
that actually generates those graphs in static frequency. So the ones you said, the static frequency graph.
Okay.
It's now generating a graph in that, so you potentially could use that to help isolate what's going on.
Yeah. I might need some Loctite there, Killa. Depending on which screw it is.
Yeah. Metal screws, so screws into, if you got like a metal gantry.
Yeah.
And the screws are going into metal, those are more likely to fall out than screws going into plastic.
Okay.
Because the plastic acts as like Loctite. So when people throw up their accelerations per hertz to like 200 and excite it, those screws will fall out if they're not kind of Loctited in, if you're doing that.
Okay.
I know Monolith recommends that if you're using a Monolith gantry, they like you to excite it about 125 to 150 hertz. I'm not quite sure on the reason, but it's probably because to isolate any other or have the resonant frequency stand out.
Okay. So I remember when I was working on my Mercury, this is a few months back. I think it was doing the APH was set to 75, and my graphs were just coming out looking horrible. But then someone told me to change that to 150, and then boom, all of a sudden the graphs were just looking great.
Yeah, it could be masking it. That's the biggest problem.
Masking it at 150.
Yeah, that's the biggest problem with setting that value really high, is that you're putting so much energy in the system, the resonant frequency kind of pops out. But things that potentially could be causing mechanical problems are still there.
Yeah.
There's not being accentuated. So when you make a print and you're like, well, why the hell am I still getting, ripples, ghosting, resonance, whatever you want to call it, and I'm using this thing correctly? Well, you kind of mask some mechanical problems.
Yeah, because you pump those numbers up. So
you
went to go look for the you went to go look at it from the performance aspect, that you didn't look at it from the diagnostics aspect.
Right.
So you kind of like a car when you're looking for, you're trying to diagnose something, but you get your foot on the gas.
Yeah, and you can't hear that little tick 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 of something in the engine, right? It's the same. Yeah. It's the same.
It's kind of like when I traded my last car in. They wanted to take a look at the car, so I just put my foot on the gas, and they couldn't hear the lifters. But okay, so that we were talking about something that made me think about the vibration profile.
The excited frequency was the last thing we were talking about.
I remember what it was. But yeah, so I think like the big takeaway here too is an input shaper. Yes, Dan, I do have a ShakeTune addiction.
It gets very addictive.
Yeah.
I mean, like the hardest thing for people to do in this, when they start running this, is knowing when is good enough.
Yeah, and that's why you said that I'm the first non-Voron to have the unicorn chaser tag.
Yeah, so I created a group in the Voron Discord for people who just would rather get perfect graphs and the prints be damned. And it's called the Unicorn Chasing Club. And you bring perfect little graphs, input shaping, and we look at all the graphs, and if they're good enough, you get a little seal with your name on it, and yeah, you were the first one non-Voron to do it.
Yep.
You're actually the first non-Voron to even ask. I will say, to join that club, the V0 is probably the hardest to. If you're like, oh, I'm gonna get my V0. It's the hardest to get perfect.
Is it?
Oh yeah, it's the belts on that thing, the tension mechanism. I mean, I haven't seen anyone with Tulip try to do it, which is a mod to the gantry. But with standard Voron V0 parts, it's really hard.
Yeah, I have not built a V0, and it's not currently on my list of builds for the next few months. So let's see. My main peak on X is at 38, with a secondary much smaller peak at 61, which seems really wrong. So it's probably similar to this, just shifted.
If you can post those graphs on Stream Chat and Armor 3D's
Yeah,
Discord, we can take a look at it. We can talk about it.
yeah, Cowbite. If you want to post your graphs up in the Discord, go ahead and do so, and we'll
just
share.
Tell me which printer it is.
Yeah,
but, not always may not have the right answer for your printer, but hopefully give you some tips on where to look.
Yeah. Post the graph and the printer specs on it. So going back to the dashboard and looking at the options over here. So we covered the compared belt response and the axis shaper calibration. Thank you, Dan. I'm gonna pin this.
All right, let's talk. Can you pull up? Good God.
Do you want to move to vibration profile?
No. Let's pull up Elmo Skillery from your Discord. Let's talk about that.
All right, so let's do that. Let's. All right, so
I reprinted. So it's an Ender 3. It's like yours. It's Ender 3 NG.
okay.
While he's pulling it up, can you are you using CAN bus? And if so, what is your frequency you're using? Or what transmission rate are you have on CAN bus? So the reason I'm asking about CAN bus, or I was asking you about CAN bus and what your speed is this is something you will see when your CAN bus is too low.
So I should also point out this is the belt comparison.
Right, you'll see it here too.
Yeah.
So baud rate is baud rate or whatever. Thank you, Spitz. Yeah, so if you have a too low, 1 million is what you should be having. A 1 million baud rate, 1 million speed when you're running ShakeTune, because it's so much data coming so fast over the line. It's LIS to deduct. It's an LIS. Yeah, turn off sweeping. Turn off sweeping in that case. You can turn off sweeping by setting the sweeping period to 0.
Yep. I will show that. Actually, right now, I think that's
Yeah, but that graph that she showed is very common with a very low CAN bus speed. 250, 500,000. You'll start seeing stuff like that.
Okay. Yeah. So for the sweeping speed, you just go to your ADXL config. Where's mine? Right here. And this is what you're wanting to add right here.
So Clipper defaults those. So if you put nothing there, Clipper's going to default to sweeping at 400. So really all you need to add there is sweeping period : 0, and that disables it. But if we go back to his graph, there's something else we can show in his graph.
Yep. Let me pull that up.
Generally, even in Belt Shaper, if you've got something going on at 125 hertz or around there, you're looking at toolhead.
Which one is this again? Sorry.
His alpha spikes.
This one right here.
Yeah, both of those. Anything happening around 125 hertz, I'd have you run Belt Shaper, right? and you're looking at tool head. Now you said ENG. Where's the tensioner in the ENG?
They're in the front. So the tensioners are in the front corners. That you could also take a look at how your belts are secured in the tool head as well, because the way that the belts are held is by these little clips in there. So I would make sure that they're secure and they're pushed in all the way.
Yeah, you shouldn't be getting that on your newest graph that you print.
Thomas, you're running a stealth burner on the NG? Yeah, but that shouldn't. The tool head itself shouldn't matter because the carriage is the same, and that's how it's mounted. So, I guess the tool head does matter. But if we're talking about the belts, the belts are routed the same way regardless of the tool head.
Yeah, and you shouldn't be getting that spike on your
tension pulley was stripped. Tension
at
pulley.
200 hertz.
Thomas, you talking about the Ender 3 NG, or are we talking about a different printer?
So stealth burner on an Ender 3 NG.
You can. Someone made a adapter.
A mod?
Yeah, it's a mod. Yeah, it's not native to the NG. The NG has its own tool head. The front left pulley stripped.
If you want, post your input shapers and let's see what they look like.
Oh, here we go. So
that's his.
So this is before you reprinted the tensioner, and this is after. Yeah. There's still something going on here.
So, yeah, it shouldn't. It should be flat.
Now, could these bumps over here, could that be related to the sweeping, or?
It could be.
Okay.
I would say more. See that zero at zero? See that little notch?
This right here?
Yeah.
Yeah.
That's sweeping related, and then it might be putting an offset on stuff.
Okay. Yeah, run it again without sweeping.
Yeah, it might actually look worse. Just to let you know. But yeah.
I mean, I guess we could say the silver lining is it's all in the green.
Yeah. Its tension looks about even.
Yeah, I was gonna say the tension looks even. It just looks like there's something going on in there.
Something mechanical.
Reth's channel is in the description.
Description?
Yeah. While we're waiting for, I don't know, Thomas. I don't know if you're gonna post up. Oh, we got Cowboy's graph. Okay.
So, is this an LIS2DW?
This is.
No, I don't think so.
I'm not sure where it would say that. So
it will. If you open, actually no, the previous graph, or the one we just opened. Cowbites.
Yeah.
Okay. So you can also tell there's a couple ways to tell it as DW. It's the laser light show.
The laser light show. Okay.
The other one is that the graph won't go all the way to 200.
Okay.
Because of its bandwidth, its internal filter, you'll have white space between the end right before 200, so the values won't go that high. This is an NGNT. So I don't know an NG. I don't know that printer, which is why this is very printer specific.
So just to give you a little bit of information about the setup of the printer. So the NG it's Core XY, and it uses linear rods and bearings. They're 8mm rods, for X and Y, and
can you open that graph again?
Yeah.
I'll give you some hints on how to read this thing.
Yep.
Even if you don't know anything about, which I don't.
So he said he is using TMC Auto Tune as well.
Yeah. So if we go, so you can look at the individual components of this graph. So the ADXLs, the way they work is they have 3 axes internal to them.
Mm-hmm.
They have an X, Y, and Z. And what Clipper does is it measures all 3 of those axes, but it only cares about the combination of those axes, right? So it's all the values you get in the legend are based upon the addition of X, Y, and Z. So if you move this graph over a bit, so I'm not covering up the legend.
Yep.
Yeah, like this.
I can only make it bigger or smaller.
Okay, so if you look on the legend here, the purple is X plus Y plus Z. So that is the addition of all 3 axes. But it also breaks it down in a per axis basis and gives you a color.
You got red for X, green for Y, and blue for Z.
Right. And what you can do is use those individual axes to diagnose a problem. So this is where tool ADXL placement comes in. So if this was an EBB36 on a Voron, that peak 2, that green line on the peak 2, I would say that's going to be most likely your umbilical, and it could be your umbilical, but it's going to be your tool head. So you have X and Y, right? It's going to be a Y rotation on your tool head. That's what's going to be doing that. It'd be an RX, because that's Z. The green is going to be Z. It says Y in the chart, but I'm sure it's the Z component
because of the direction of the placement of the ADXL.
ADXL, yeah. And you can figure this out by putting the X.
So this is a cartographer.
Cartographer, and that's a Y. So what's going to cause? You got no Z though, right?
No Z. Z is the blue line. That's all the way at the bottom.
So a cartographer has his ADXL flat. And when the ADXL is flat, the Z is going up or down. It doesn't matter. It's on top or bottom of that chip. And your X and Y coordinates are going to be like you imagine, like the planar of your bed. So if that's an X, it means you're getting more Y rotation. Y is still going forward when you stop, right? Like you're getting this movement. That could be because of what we were talking about. With the bounciness, but you'd see that more as a Z than a Y. So it could be that when you pause it, right? So you want this thing to stop, and it's just going to keep going. So it could be you're not rotating enough. I'm trying to visualize how that would be, because if X is this way,
you want to break out MS Paint?
No. Visualizing and attacking. I would swap to the EBB36 if you have one, or toolhead one, and see if that Y turns into a Z or something like that. See if you still get the same hump. If you do get the same hump, I would suspect it's going to be a toolhead rotation issue or an umbilical pulling on your toolhead. If that goes away, then it's going to be something to do with the EBB36 pendulum, because it's also a pendulum. Right? I'm sorry, the cartographer, because it's held down. It's not really fixed or firm to the rail. It's down, and it has the ability to swing like that. We're not talking lots, right?
Yeah.
So I would compare it to that, and then see, okay, does it have the same shape? Am I getting the same peak at 2? Or I'm getting something different, and then compare. But I would suspect that when you move to the EBB36, if that remains and turns into a Z or something like that, or just remains, it's toolhead nodding, rotating around the X-axis or umbilical. If it goes away, I would suspect it has to do with the mounting of the cartographer. Does that answer your question? I hope it does. But once again, this is like, you have to figure out what's going on with the ADXL and where the placement is, because all the graphs start changing when you move your ADXL around. I hope that helped.
Yeah, he said he has cartographer, but it was using the Nighthawks.
This is a Nighthawk toolhead board.
Yeah.
Oh, okay, yeah. I would look at
The
umbilical. Mm-hmm. If it's a Nighthawk toolhead board and you got that, yeah, that stupid cable has an effect on the thing. Yeah.
I mean, realistically, with the NG, there's really no good relief on the back of the printer, like in your in your umbilical video. I always say that word. I get that word.
Umbilical?
So, umbilical. On your umbilical video that you have on your channel, and you show your tridents, and it basically goes from the tool head to the top of the back wall. There really isn't a place for that on the NG. So basically, there's a wire pass through that's in the back.
Round? Is it a round wire? A piano wire?
No. So for the
you're talking the umbilical pass through. Okay.
Yeah, the pass. So it's a spot for a PG7 gland.
Okay.
So and it's right next to the rear left stepper motor. So it might not be the ideal situation for the umbilical.
So you guys with the NGs might want to look into doing something like Prusa is doing with the XL. And if you go to Stealth Changer's GitHub, so it's Draft Shift is the group that's doing the Stealth Changer. On the main page of their GitHub, they have a section called Wire Management or Cable Management.
Okay.
In there is a mod by a guy named Nimi. It's actually N3MI. It's Nimi, and what he's done is created TPU connectors, which are pretty good. Pull it up. I'll explain it to you. You guys may be able to mod it for your.
What are we looking for?
I would just type in Draft Shift GitHub.
Nope. Let me do this. Oh, right here.
Yeah, and then you want the I think is this umbilical plates V2. They may have moved. Yeah, the picture. Okay, yeah, keep going down. You should have a better picture of it, of how this thing works. Okay, come on. Umbilical restraints. So what he uses, so that's a good, does he have a whole better picture of the whole thing done? Okay, there you go. You guys may be able to use something similar to this. You'll have to obviously make some adjustments to it.
Yep.
But that's all TPU, which does a really good job of sticking to umbilicals and Bowden tubes. And in it, he has flat spring steel. And flat spring steel has the added benefit over piano wire, and that it doesn't easily flop over. It will hold its shape of how it wants to be.
I can see that right here. Yeah.
Yeah. So, and you bend it a little bit. You want to heat it up and then bend it.
Yeah.
But piano wire has a big tendency to just flop over, and it's not holding the arc that you want it to, or the arch that you want it to do.
Yeah, I actually run the piano wire on my SV08. As you can see I don't know if it's in picture right now, but you can see how it has that solid arch on it.
Right, but it's also leaning.
It is leaning, but it's leaning less because I have this PTFE tube coming off of this side.
This one won't lean.
Yeah, and then I also
because
run.
it's flat.
the piano wire on the Mercury.
It doesn't have the.
Yeah.
So this would be something you might want to look into.
Yeah,
I mean,
definitely.
he does have a piano wire option, but I would go with the flat spring steel.
Okay.
And it was fairly cheap before the tariffs.
And biblical versus cable chain, which is the best?
I like umbilical. The cable chains. I don't think we implement cable chains correctly, and the fact that I don't think you're like a Voron's, right? You got like 24 wires in it, and we're kind of overloading those cable chains. It'd be better to run, if you want to do a cable chain, like I say on a Voron, it'd be better to run a cable chain cable, like an IGUS cable with all the wires in it. But I stopped using cable chains after my second wire broke.
Yeah. I only have one printer that's using cable chains, and that's the Stealth. That's the switch wire. And I'll be perfectly honest with you, that was my least favorite part of the whole build.
Yeah. I mean, I got my switch wire, and it has the LDO cable in it.
Mm-hmm.
And perfect use case of that.
For the LDO cable you're talking for the Nighthawk?
Yeah.
Yeah, that same. SV. That's what mine is too. But just the cable chains themselves, I don't like cable chains personally.
Yeah, but on a switch wire, you really don't have an option. I mean,
no, you don't. Yeah,
it works.
It's definitely the better option for a switch wire.
Sounds like I need to get on making cable options too.
Yes, you do, Mike. So Mike does wiring.
Okay.
Mike does wiring. So that's his thing.
3DO makes a nice cable. I really actually for umbilicals, I really like the LDO cables. They're well built.
Mm-hmm.
Second to that would be, I mean, IGUS and 3DO. I've used both. IGUSs are stiffer, but they also retain memory better. So when we're talking about memory and wire, it's once you bend it, does it stay where it's at?
Sounds like we need a wireless tool. Yes, that would be ideal.
I don't know where we're gonna get all the power, but yeah, we'll use Tesla's wireless power.
You guys sprinkle some pixie dust on there.
Yeah.
All right, so do you want to move on to the next one?
Yeah, we can move on.
The vibration profile. This one.
Yeah, we can do that.
This one's a little heavy.
This one's heavier.
So
this one's not as nice.
So this one might bring up some questions. So do we want to look at the 0 to 200 one first, or the?
Yeah. That's standard test. Let's do the standard test. Oh, it's very pretty. Okay,
your results may vary.
Yeah, so this test is heavily motor dependent. So input shaper, everything we've done up to this point has been discussing basically mechanical issues and max external internal perimeter accels. That's what you get with input shaper. That value, that speed value you get at the very end, is your internal or external perimeter accelerations. Your internal perimeter accelerations can be about 500 to 1,000 faster than your internals. The negative of going too fast in your internal perimeters versus your external perimeters is that you could get little squiggly lines. You get some artifacts that potentially could translate from your internal perimeters to your external perimeters. So, but that's all Excel. We've been talking about perimeter Excel up to this point. This now is testing your motor's vibrations. And this has to do with your internal, external perimeter speed now. So this is why when we run this test, we don't mess with the acceleration. You can. But if you make the acceleration too fast in this test, you end up turning it to an input shaper test and not a motor vibration test. So that's what this test is doing. That's the gist of this whole test here. This all 6 graphs are to characterize your motors and the speeds they can do and the vibrations at different angles. So which part would you like to talk about first?
Well, let's just start in order. Let's start with the polar energy profile. Because I think that is I learned a good amount from that, and I think and I know that when we had our initial conversation about this, that we spent a decent chunk on this, and then went back to it. So,
the polar vibrations and the vibrations heat maps.
Just real quick before you get started on that.
Okay.
I'm going to let's see. I'm gonna just do this real quick. So while we're talking about this, because there's a lot of information in this, I'm going to post the link for the giveaway. Okay, so it's the same giveaway we do every week for atomic filament. Excuse me. You have the chance of winning a spool of PLA, PETG, or ABS of your color choice. No abrasives, no ASA, etc., etc. But yeah, go ahead, and here is the link to the giveaway. And I will replace the pinned comment so it's up at the top. So yeah, go ahead and fill that out while Reth is talking about the vibration profile.
All right, so these are basically it's one way to visualize the vibrations that are happening in your system and to compare your motors. So you want both of these graphs to basically be just completely orange. And what that's telling us, if they're completely orange, is that your vibrations are basically the same vibration throughout, right? There's no highs, there's no lows. It's kind of just everything's kind of vibrating the same. Doesn't happen. You don't want, but you do want more orange than black, right? So the oranges are closer and stuff. And the polar vibrations heat map is basically where are your vibrations happening along the polar circle, right? The unit circle. And you can see that you're getting most of your vibrations at kind of 2 sets of angles. So like around 30 and 60 degrees for one motor, and 120 and 150 for the other. So what is that saying? That's saying when your motors are, if you imagine your motors, right, you have 4 inherent axes for a core XY. You have A and B, which are when one motor is working only on. So you'll have like 45, I think, is A. I could be wrong, don't quote me on this, but one motor is 45 degrees. So when it's moving in a 45, your tool head's on a 45 degree on a core XY.
Yep.
Only one motor is running. The other one is 135, which is the other motor. So when your other motor's going, you're only moving one motor. Those are probably the.
Those are the green. Those are the green areas.
That's the one above, right? But it's also for this. So you're not really going to get vibrations. You're going to get the least amount of vibrations when only one motor is running, and that makes sense, right? 2 motors running, you got 2 things vibrating.
Yep.
So on a core XY, when you have the motors running kind of in opposite directions, or they're running together with the same number of steps, you get like your X and your Y movement. Anywhere, and those are your 0 and 90 degrees. Anywhere between that, though, you have one motor moving more than the other motor. And when that happens, the vibrations aren't in sync, and they create more vibrations. And that's why you see that bright yellow in the polar vibrations heat map, and you see the angel wings in the vibrations heat map. And what that's basically saying is the motors aren't in sync. One motor is creating a vibration, and the other motor is creating another vibration because the motors aren't moving in sync with each other. They're not doing 1-to-1 for the X or Y, and one's not being held steady for the 45s or 135s. which is why at like 120 degrees, at 150 degrees and 1630, you get really bad vibrations. And that's going to be in every print. So you can minimize that, though, by how fast you run your motors, or how slow you run your motors, depending upon your perspective. And in this polar vibrations heat map, there are mini circles inside. And each of those mini circles is a speed. And so that polar vibrations heat map correlates with the graph above it, where that says symmetry, 100%. And so you take that and you move it upward, and you can see now in that the greens are your lowest, and the one above the polar vibrations heat map, the green triangles or pizza slices are your best, your lowest vibrations, ergo your best angle to print at, which is going to be your 45s and your 135s. That's what that's showing you. But what it's also telling you is when you start looking at the shape of it, your next best after that are your zeros and 180s. I'm sorry, 0 and 90.
When they're both working together fully.
They're both working together because if you look at the shape, it bows in on the edges of that.
Mm-hmm.
So your worst, so they correlate, right? Because you can see that like 60 degrees equals, over there, it's closer to 60, 65, 70 degrees. This one's saying about 7 degrees is your worst vibration.
Yep.
And those are also speeds. So you can see that, and that so far, I hope it makes sense of how I've been explaining it.
Yeah. So I think one thing that we could probably go over that helped me understand a little bit more is when you mentioned like the angles, like so basically the way that I remember, and again, I got soup for brain right now, but you want to orient your parts on the build plate to optimize performance. So it's all about placement, so that you're using those green areas more so. So when you're slicing your part, you want to basically slice it while you're looking, like as if you're looking at this image, so that you can maximize the movement of the printer in that area. Is that the right kind of track?
Yeah, you're about 90% of the way, I think.
Okay.
Of what it is, but you wouldn't use either one of those two graphs we just talked about.
Okay.
To figure that out.
Okay.
You would use the other two graphs, so the global speed energy profile and the angular speed energy profile.
Okay.
So if you take the vibrations heat map and you basically take all the angles, take the Y's,
yep,
at the speeds, and you added up all the vibrations. That's where those lines, you see those peaks, those lines in it. The resulting graph is the one above it, the global speed energy profile.
Okay.
Okay, so basically, you can read the global speed energy profile as the summation of all of the vibrations in the heat map.
Okay. All right.
So, right, so it's an easier graph to follow too.
Yes.
So this is saying no matter what my angle is, the global speed energy profile, no matter what my angle is, this is its relative better speed zone compared to other areas or other speeds, right? So that's why you have like basically 0 to 47 is a good speed. And so the green zone, okay, back up again. The green zones here are based off of the max peaks. So the green zones are relative to your system on your motors. Does that make sense? I hope I'm not losing anyone.
Yep. Nope. I'm following. I just popped into the Discord chat to see if there's anything new in there. So You're good.
Okay.
You're good.
So you can, from this graph, this middle one here, this global speed, you can tell how good someone's motors are. However, there's caveats with that. TMC, you need to have TMC auto tune installed.
Okay.
Because once again, it's kind of like the damping ratio in input shaper. For TMC drivers, Clipper just gives the default driver for every motor out there, right? It's just like, okay, these are good enough to work on all kinds of drivers. We're going to put them in, but they're not really optimized to your motor. So what Andrew did is he went into the data sheets for the TMC drivers and pulled out the formulas for how to optimize them. And then he pulled the formulas out, and he's using your motor values. That's why if you go into motor database, yeah, that one right there, it has, the resistance, inductance, holding torque, max current. Those values get put into the equations to pop out driver or your TMC driver configs to optimize your motors effectively, right? The whole thing gets optimized with these values.
And he has a lot of motors in here, so there's chances are your motors are in here.
And if your motor's not in there, if you have the data sheet, you can create your own motor spec and use that. In the main page, he tells you how to do that.
Yep.
Now, I will say there's another person that did something similar. It's not a TMC auto tune, but it's a test. It's let me see if I can find the guy's name.
This is what Reth was talking about, by the way, everyone. My motor constants, my custom motor. So if you for some reason are using some rando motors that aren't in this extensive database, you can get the data information on it and plug it in here.
Right. God, I forgot the guy's name.
And the installation of this is straightforward. Okay, don't do what I did and overcomplicate it, because then you'll just get yourself confused.
And there's not like, oh, do I need to include, like ShakeTune has, you have to put the word ShakeTune in it.
No,
there's nothing like it.
It's
works.
Just this right here. Your
anywhere in your config.
Your TMC auto tune X and Y. I mean, I guess you could do Z and the extruder if you want to. I don't have Z and extruder in mine. I just have X and Y in mine. But this is literally all I have in the config. And that's after I did the install. So I did the install, boom, did that. Added the update manager, boom, did that. And then went and put this in my printer.cfg right underneath my stepper motor section. And that's it.
So there's another way to do this whole TMC driver, because this section actually matters for this test, the vibrations test. I put it in chat, and it's called Chopper Resonance Tuner. Now this one will have you run tests on your motors, on your systems, to pull out the TMC drivers. They will be different than ShakeTune gives you, than AutoTune has. There'll be different values in AutoTune. However,
where do you put the link?
I put it in the stream chat. Hopefully, I'll put it in.
I don't think so.
No, it didn't. Maybe it killed it out. Okay, let me put it in your Discord. Let me find your Discord. Where's the Discord? There we go. In Discord. So this one, you run a bunch of tests. It runs a bunch of tests, and you have to go and analyze the data yourself and figure out what it says is the best. There's like 4 or 5 TMC driver variables, and you figure out which is the best, and then you use those, put those in to your TMC driver section for the motors X and Y, and then you rerun vibrations. You use one or the other. You can't use them both. And you can compare it. You can see which one works better for you. I personally like the TMC Auto Tune because there's nothing I have to do.
That's what I'm leaning towards.
It just works.
That's what I'm leaning towards. Yeah, honestly, this one kind of lost me when I looked at this right here.
Yeah, and I will say the write-up for the 51s, if you're using 5160s, which I have,
I am on one of them.
The directions were not very good for 5160s. 2209s, fine, all day long you could use this, and the directions tell you how to do it. But once you get past that, the 5160s no good. I didn't like the directions.
Yeah,
maybe he's changed it.
Once I spoke with you, and I think it was Spitz. Wasn't it Spitz in the?
Yeah.
Once the three of us talked about this, and I pulled my head out of the dirt, and realized that I was overcomplicating it.
Oh well, this is easy. This is the easiest thing we'll do to your.
I don't know if you remember, but I went through and I was like adding all of this stuff to my config, and Spitz was like, "What are you doing? Stop doing that."
And to be fair, all you need is your stepper X and your stepper Y for this.
Yep.
You don't need Z.
Yeah, that's what I was saying. That's when I realized that all I needed was that right there.
You don't need the extruder either. You just really need X and Y. But we Andrew and I ran tests and we compared this to the Chopper Resonance Tuner.
Mm-hmm.
And we actually found some errors, and we actually used the Chopper Resonance to fix auto-tune in some of its calculations.
Okay.
Because the TMC drivers for at least the 2209s are not very clear on any of this, not as clear as they should be on all of the Chopper tunings and stuff. But yeah, so this is a test. You want to install that. It'll make your motors better. So back to this guy. So once you have that, then you have the global speed energy profile. And this one, you can use it to compare motors between people, but you can't really use the energy, the value on the y-axis to compare between people.
Okay.
If that makes sense. You can use kind of the shape of the graph, because that's the graph here is, in the middle, is a collection of all of the frequencies.
And we're talking about this global speed energy, the one right in the top middle.
Right. And because each speed is a combination of all angles for this one, this is what I like to call the speeds you would use for organic shapes. Excuse me. Organic shapes. So that would be, things like this, like a little flexi dragon, or, a circles, something like that. You would use these speeds because it's the speeds that produce the least amount of motor vibration.
Now, when you say these speeds, you mean the speeds in green?
In green.
Speeds in green. So we're avoiding the speeds that are not highlighted in green. So like, don't set speeds for 175 or 50.
Yes. And surprisingly, 100 is a bad speed for a lot of printers, but it comes in default in a lot of slicers.
Yeah. So it's like so when you're setting your speeds in your slicer, don't go ahead and set your outer walls to you want to slow it down for quality, but so you slow it down to 75 for quality, and you're
75.
75 would be a bad one. You'd be better off at, was it some 85 to 90.
That would probably produce some results too. I mean, yeah, it's low relative, but it's kind of like you got a fine line in there.
Yeah. And
chances are, as you're speeding up and slowing down, you're gonna get it.
Shadow
Queen.
There's
like a huge dead zone in a lot of these. Basically, you're looking at from 70 to about 105 is a dead zone.
Yeah. So at this point, you might be better off, slowing it down to like 110 for quality.
For 110, or you mean speeding it up?
Yeah, or maybe going to 60.
Okay. 150. Yeah, you're gonna be down at like 60 or up to like 115 ish.
Yeah.
Yeah, there's a huge, but we're only talking external and internal perimeters.
Yeah. Yep.
Right. So infill, run infill as fast as you want. Run solid infill, as fast until it looks ugly.
Yep.
Same with top solid infill.
Yep.
But for perimeters, you're gonna should be in the greens, and some greens here you're gonna have to say, look, is that between 75 and 100? Is that green zone worth it? Right?
Probably not.
Probably not.
Yeah.
So that's that graph. The next graph over is the angular speed profile. This one you should use for structural. Yeah, you should use that for structural elements. Can you move chat by any chance so that we can get a better?
Yeah. Chat. No, I want to move chat, not. So chat. While I'm making these adjustments, are you guys understanding this? Like, is there any confusion over this one? This test took me a little bit to wrap my head around. So, if you guys have questions about this,
Amanda, you have no idea what's going on. Are you completely lost, or just it's a lot at you really fast?
You just showing up now. Martin didn't send you in here. Martin didn't make you watch from the beginning.
Nah. So, if you have a question, you want us to go back to something, please let me know. So the angular speed energy profile, you got 4 values being shown on that: your x-axis, your y-axis, and your A and B axes. Your A's and B's, the graphs of them should be exactly the same, right? Because the A motor should be moving the same way the B motor is moving. And the same reason why your A and B belts should be exactly the same. But we know they're not, right? And you can see that here at around 30 millimeters per second. Your A belt has less amplitude than your B belt.
Okay.
But your X and Y's are the same. So that's fine. What you use this graph for is you got to find your own valleys in this graph. Excuse me. And you would use that to set the speeds on structural parts. So if you align your model in the X and Y axis, so it'll be like front to back on the bed.
Yep.
You want to find speeds that are in between the valleys, live in the valleys. So you're talking like 125 and faster. Here you could use the middle now. And you could use that middle section, knowing that as you cross an angle on a turn, the noise from the A's and B motors will show something.
Okay.
But like if you're like most 3D
you're talking about this section right here?
Yeah, that will show up as you make a turn.
Okay.
Right? So let's say I have a box, just a box.
Yep.
Right? And I orientate it along the X and Y axis. Right at that corner that it makes its turn, it's getting into those zones, the AB motors vibrations. So you may see vertical lines along
Mike.
along the corner. I just need a graph. Yeah, Mike, just need a graph every now and then. But you can use this for structural because you do get a wider range of speeds out of it. So that's how you use these 2 graphs. If you do it in 45, if you line yourself at the 45s, whether it's 45 one way or the other, it doesn't really matter. So 45 or 135, you do the exact same, except you would use the orange graphs to set your speed. So this one, if you angle it at the 45, you actually start getting good speeds on that angle, that flat angle that's along the 45, starting around 80 millimeters a second.
Okay. And then you could just keep going until 200.
Until you need to make the turn.
And
once you make a turn, you're going into the X and Y direction,
which you want to get out of there around 125.
Right. But you're just going to set a perimeter, and hopefully your corners aren't like big swooping angles that you're going to see, right? Like, so most printer parts, you just got that little curve that you'll go over.
And then just to clarify, what we're talking about here is in those speeds is you're going to see VFAs.
Yeah, you'll see VFAs.
The VFA. So,
or you'll see weird stuff too. Like, it'll look like ghosting, but it's not. It's like you'll see like bands sometimes.
I think I threw away those test pieces that I had. It probably wouldn't translate well to camera right now, anyways. But yeah, it's like the ripples. I think I heard someone refer to it as like salmon skin. It's like it almost looks like fish skin, like the scales.
Yeah, but the difference is that the VFAs produced by motors, while they may fade also like ghosting, they're vertical and they go through everything.
Yes, Mike.
So what?
You said like Z ringing.
Yeah.
So
no,
so it's not
Z ring goes like this though.
Yeah. Oh, yeah. So yeah. So it's not ripples going.
No.
John, break out paint.
It's if you can imagine, it's like ripples in the water, like a wave, but it's not necessarily tied to a feature.
Yeah, it's not going up. It's like going like around, like
it's going
across.
Yeah, and it's going. It looks like this, like like the corrugated roofs, right? The corrugated tiles, the metal corrugation. If you put it standing up, it looks like that.
It's on the ground. On the ground. Let's see.
All right, I gotta take a quick pee break because I drink so much coffee. I'll be right back.
So let me see if I can pull up the camera while he's going to the potty. So right here, the vertical lines. The worst filament. Oh well. Yeah, right here. So like you see the ripples and stuff in it. The very first picture is good. Okay. Oh, not that one.
All right. Too much coffee.
Said no one ever.
So someone mentioned Z banding. I forgot who that was. The Mike. Yes, it's not so much Z banding, but it looks like your bottle's printing fine, right down here or something, and then the next layer up, it's all got this band on it. It's almost like a band, and then the next section up, it's good, and then a band. That is also can happen when you're printing at bad speeds. And it has to do with the speed you're printing at and the features there, because it'll slow down, right? You got to imagine that you don't have a consistent speed on every surface of the print. So if you have, like, say, like a Voron cube, right? One side will have the X and Y, and then it has the inset Voron symbol, and the other one has the outside Voron symbol. Well, on all those sections, before it does turns, it gets to a certain speed. That speed, if you have like slowdowns, cooldown, or minimum layer times, slowdown for whatever, any sort of auto slowdowns, those auto slowdowns will actually send you into bad speeds.
Yes.
So the first thing you want to do if you want to get like try and get better prints is turn off all of the slowdowns. And if you have features that need extra cooling, just slow the whole print down. because you will get like these. Either you'll get that corrugated look, or you'll get like the stuff. It kind of looks like Z banding, but it's not.
So I guess to maybe add to that, and correct me if I'm wrong. If you really wanted to add the slowdowns, then you just do the math and do the percentage part, right? You could go in there and you could just try to put in there, be like, okay, so for this feature I need to slow down, but I'm gonna tell it what to slow down to.
So that works for the slicers, at least that I know,
like overhangs.
They can do this. Yeah, the slowdown for overhangs great because you can actually set a speed.
Yeah, or right? Do you mean like the excel to decel?
No. Like minimum layer time is one.
Minimum layer time. Okay.
So that's an auto slowdown.
Okay.
Right, because if you say a minimum layer time of 10 seconds, and it's printing at 150 millimeters per second, and it gets to a smaller section or a section of the model that only will be done before your minimum layer time, it will slow down the tool head to meet that layer time.
Yes.
That's an auto cooling feature. That quite frequently will just mess up you're like, why I set the speeds right, it's still showing this. So all of your autos, that's one auto slowdown. I think there's another one, but I forget its name.
Let's take a look.
Minimum layer time, auto cooling. Auto cooling's a bad one. Turn off auto cooling. You want that tool, the part cooling, to be consistent throughout the print. Because
these are all in the filament settings too.
I believe so.
They're all in the filament settings. So I know I don't have my slicer screen shared right now, but it's where is it? I just saw it. So in cooling, you have your layer time. Like for example, this default layer time is at 50 seconds. That's crazy. I don't know.
You're gonna be slowing down.
I don't know why I have that set to 50 seconds. But there's the slow printing down for better layer cooling.
Just that's turn that off.
Yeah,
you are so much better. You're gonna get so much better prints if you just slow the entire thing down.
Yeah.
If you notice parts need more cooling, or they're not coming out right, increase your part cooling fan.
Yeah.
Set that higher, but keep it consistent. So you have that. You just jack that up. Slow it down. You can slow down Excel, but those auto things will have you chasing your tail and trying to figure out what's going on.
Yeah, and then next thing you know, you'll be pissed off at myself and Reth because you watch the stream 6 times and you set your speeds to the green area, and you're still getting these artifacts, and you're like, well, what the hell? I did everything those guys said to do, and blah blah, and it's check your layer time, check your slowdown for cooling, check that stuff, and like Reth said, just turn it off.
And if you really
consistent
like
speeds are key.
Consistent speeds.
That's right.
But if you really like to use them because you're like, I'm not going through all that, then slow the Excel down. Just slow the Excel down. Because you got to slow something down. You got to do something to get good, consistent prints. And for sure. Yep. So this is now. So some motors like to go fast. The 2804s are a known motor that likes speed. It likes to be above 100 millimeters per second. In that sense, when you get motors that like speed, and you can tell that from the previous 0 to 200, where in that the peaks are like these peaks, and they started to go downward.
Mm-hmm.
Right. If you look in your Discord right now, you have Calbright did another graph.
Okay.
He did the machine vibrations. This is a good.
Oh yeah, let me pull that up.
Segue for this.
Let me pull that up. So Yeah, because his looks different than mine too. So
yeah.
So it's a good
Okay. His motors, as they currently stand, I don't know what they are, do not like speed. Because you can look at this global speed energy profile and the angular speed energy profile. And as I run this faster, right, so faster than 200 millimeters per second, you can. I'm not saying you can't, right? None of this is saying these motors won't do it. But as you run these faster, I believe you're going to see the vibrations start to go up and up and up and up.
The graph does look like it trends upwards.
Right, versus yours, where it's going downward.
Yep.
So it likes the speed.
Yep. So, Cowboy, what motors are you running?
Yeah, and I would definitely install. So it tells you right now, TMC AutoTune not installed.
Yeah, TMC AutoTune. Yeah. Yeah, because now could be it could be a good, thing for you to see is, actually, Reth,
can you open that up again?
Yeah, it might even be a good question. With TMC AutoTune installed, will this change?
Yes, it should change a bit.
Okay.
And we're not, I mean, I'm not going to guarantee it's going to be like a drastic, miraculous solution, right? It's just optimizing for your motors.
Yeah.
So it's trying to reduce the maximum vibrations, which is on your energy side. But you can see here that compared to yours, all of the vibrations are in certain areas. Right, because you got this dark area, like the vibrations aren't even. They're coming in certain areas, and so you can like the cross. You don't have the German cross anymore. You have a standard plus symbol cross. This guy Cal standard plus symbol. So it's basically if it's not an angle, he's going to get kind of consistent vibrations across the X and Y's, and you can see that where his angel wings are now, he's getting these primary angel wings with the secondary angel wings down there. And so his good zones are more limited than yours at speed, at something like over 100. He's got from like 170 something or other, right?
Yeah.
But really, he's got
three good areas. That's 3 sweet spots, you could say.
But he actually has less, because if you look at the angular, so if you move the chat back over again.
Yep.
Looking at the angular speed, you see that they're consistently rising, right? So he doesn't, when you compare it to yours, where yours kind of go back down to 0, or they get closer to 0. His aren't doing that. These motors aren't doing that. And now this could be the TMC AutoTune, or it could be the motors. It could also be the run current. Maybe you're running these motors too much. Those are all, it could be if you install TMC AutoTune, there's another variable you can play with. It's called PWM. And it's the frequency that it sends the updates to the motors to cycle to. It's how fast it updates the micro steps in your motors, right? Something like that. Don't quote me on that one.
Yeah, because it looks like he's running the 2209s at 1.2 amp at 128 microsteps.
Right, and we don't know what the PWM is.
Yep.
So you could potentially.
Well, is that on the PWM config?
Yeah, but I don't know what it is. I don't know how to translate that to.
Okay.
It's
fair.
I think that's. I'm not sure if it's a hex number. It's not. It doesn't the same as like 55 kilohertz or 45.
Sure. Okay. I gotcha.
But if he installed TMC AutoTune and then dropped his PWM to say 20 kilohertz, it might improve this graph. Right.
Okay.
He might be trying to change his microsteps faster than the motor can actually handle. He needs to slow that down.
And I'm gonna go back and look. Is this on a NG?
Yeah, it's the same one we're talking about.
Yep. Ender NG. He's got 48 millimeter steppers for X and Y. He said TMC Auto Tune, but the graph's saying it's not installed.
Not installed.
So he might have downloaded it, but he might not have put the items in the config. So Cowbite, if you can hear, post up what motors you're running just for curiosity. So like for example, what's that?
Go ahead. I'm reading a comment. I'm sorry.
Oh, the goal is to move the mass as fast as you can go smoothly.
Yes, that is 100% the goal. You want, and that's where jerk comes in. Like so, Clipper doesn't support jerk, but RepRap and Marlin do support jerk, and jerk is the rate of. So if we look at, we'll do some math. We'll do a little calculus here, right? So you have distance, right? That's how far we're going to print. And then speed is distance over the time. So how long does it take me to do that speed, right? Then you have acceleration. And acceleration is the rate of change of your speed. So the faster you accelerate, the more your speed is changing as you go up till you get constant acceleration. And then you're just doing that. So it's the rate of change of your speed in the positive or not negative direction. Jerk is the rate of change of your acceleration. So it's like, it literally is like the jerk you feel, right? And you change. So Clipper doesn't do jerk. It does square corner velocity. So it's a constant acceleration model, I believe. Yeah, constant acceleration model. So it tries to get to 2,000, say whatever, 3,000 millimeters per second squared and stay there, and it doesn't like to necessarily change that. But yeah, where's that coming in at? I don't know. Why am I bringing this up?
I don't remember. I don't remember. So I brought my graph back up so you could show what the TMC Auto Tune displays for the PWM. So you have the frequency target for X 55 kilohertz, and same for Y. So that way.
And that variable could be changed for each motor if you wanted to. You could say, look, one motor likes. I haven't seen this happen. Most people change it the same, but you could say one motor likes 22 kilohertz. The other motor likes 22.5. And you would be using the angular speed energy profile though to figure this out. You could fine tune it that much, but now if you compare this is from 0 to 600.
This is 0 to 600.
Yeah, and he's got these huge green swaths. If your motors like to go fast, you will always have these green swaths. There's not really a situation where it goes.
Looks like I want to stay away from 350 though.
Right. Nah, not really. I mean, if you look at the angular speed, you can see that it's your X and Y. You know, it's basically the additions of the two motors.
It's where they're crossing.
So if you want to minimize your vibrations, you'd probably be around 400.
Yeah.
Right, because 500 you get it's really low, but 400. But all
I'll probably be printing between that 250 400 area anyways. I don't usually depending on what I'm printing, I don't usually go over that.
But you can, using the rest of the graphs here, you can see how a lot of these vibrations are centered on the lower speeds. Right, like your polar vibrations heat map, they really all come together at the low speeds, and then once you go to higher and higher, you still have the angles. The 35 and the motor. Just when one motor's going, or around that one motor, you'll get more speed. You more noise.
Yeah.
When the motors aren't in sync, but in the polar angle energy profile graph, you can see that when the motors are in sync, the zeros and the 90s, you get pretty good response or less vibrations there. So that's how to read this graph. This one's all about vibrations.
So this one, when I started looking at this one I kind of I felt like I got the most. Not. Let me think this through before I just start having, just start throwing words up. But so back it up. So when people talk about they want to install Clipper because they want to go fast, and then companies are saying, oh, well, with Clipper, we have Input Shaper, and
this is the one test. I'm going to interrupt for a second. This is the one test that does not come in either standard Clipper or standard Calico.
Right.
This is exclusive to ShakeTune.
Right. Yep.
Okay.
So basically, so what I was saying, Clipper itself isn't just going to automatically make the printer faster.
No.
There's still a lot of this stuff that you need to dive into, that you need to, make sure the printer can handle it. So running your Input Shaper, like we went over, will be a good way to find out how well your machine is put together, and how ready it is to actually go faster. And then, you have your belt graph that's going to make sure that your belts are synced, and, you don't have any other type of mechanical issue going on before you run your Input Shaper. Now, to really see how fast you can go at quality is going to be brought to you by this graph. These graphs, the speeds, not acceleration. Speed.
Not acceleration.
Speeds.
Internal and external perimeter speeds.
Yeah.
So, I do have a video on how to set your entire slicer speeds, though, from this graph.
Oh, nice.
And it just gets a rough start, right? It's only 0 to 200, but it's a rough start. But you can get the basics, because that's the next question. That's a question I had, right? Yeah. How do you give me all these pretty graphs. How do I set my slicer? What about this value in the slicer? What about this value? So I do have a video that goes and takes the standard 0 to 200 graph along with Input Shaper and says, look, this is how I would set my slicer up for a printer I just calibrated using these tools.
When you get a chance, post that up in the Discord, and I'll put the link in the description of the video.
God, you asked so much from me, baby.
I know. Because if I didn't ask you right now, I'd forget.
I'm gonna forget. Yeah, I got you. If I don't do it right now, I'm gonna forget.
But yeah, so basically, what you can use the accelerations, and Reth, correct me if I'm wrong. You can use acceleration as a guide from Input Shaper, and the speed from the vibration tool as a guide. And then you want to stay in this green.
You always want to stay in the green.
You want to stay
perimeters.
For perimeters. Infill.
Right. Infill, go wherever you want.
Yeah, infill, have at it. If you can push the plastic and cool the plastic, then have at it. Have fun. Yeah. But even with ABS, you got to think about cooling.
If you're pushing these speeds.
Yeah.
But so if you want quality, you're actually going to also use some of this for your top layers. Right?
Mm-hmm.
Because as you do that faster, you will get. You want to see vibrations per se, but it won't be as crisp, if that makes sense.
Yeah, there'll be other things. Yeah,
there'll be other things.
Like you might run into maybe some extrusion type of situation going on.
Yeah.
Because there you still have your pressure advance, you still have your flow. You still or your extrusion multiplier, depending on which slicer you're using,
and those lines that you see vertically on the side, and everything you see resulting from Input Shaper and speeds on the side of your print is still happening on like a top layer.
Yes.
Right. The only thing is it's a top layer, so it may be like a little. They don't look as crisp.
And then you still have the the I don't want to call it mechanical or built-in or whatever. The VFA's from the belt pitch.
That's always
So that's going to be there. So, that's
you can minimize that, but the minimization is you can either speed up.
Yep.
So you can do it if you got the room in your graph to speed up. You can speed up, and the faster you go, it appears that it's going to minimize that. Is it going to make it 0? I don't know, but you can speed up to do that. The other thing you can do is potentially loosening your belts.
Okay. For eliminating, but that could introduce something else. So it's kind of like one of those, like, do the best you can, and just accept, like, don't get upset about the things you can't control.
Right. The other way you can fix it is adjust your pressure advance.
Yeah.
You can. I think usually people drop it to reduce their pressure advance.
Yeah, I think like the general rule of thumb is you want like the lowest possible value while maintaining, that quality from the pressure advance.
Yeah, a good place to start for that is 0.04 for a 0.4 nozzle
for direct drive.
For direct drive, yeah. I don't have any experience in
for Bowden, just take the 0 out.
Just take the 0.
So take this. So like, for example, the pressure advance on my blue NG that I'm running, I'm running 0.3 pressure advance. So
0.
So it's significantly higher than on a direct drive, but also don't use that profile on your direct drive because your print's gonna look like dog crap. Like it's gonna look horrible, and then you're gonna think that you're gonna have a huge issue. You're gonna think like you got a clogged nozzle, or or something's going on, and you're gonna be thoroughly confused because you're not gonna be thinking that you just missed the 0 in pressure advance. So
the other thing you can do is, besides adjusting pressure advance, is you can adjust the pressure advance smooth time.
Mm-hmm.
And I think that's how much time it gives to react, I believe. Don't quote me on that one. It's been a while since I've read the documentation. But
I actually, I've never tuned or adjusted smooth time because I could never find anything on it.
You can get by with the 0.03. So it defaults to 0.04, just like the same as the default kind of for a 0.4 nozzle. You can reduce it to a 0.03. So if you're like tuning it and you just can't get that last bit out, you could always drop that down.
Okay. So Gil has a question that we did touch on this earlier, Gil. The best optimal location for the sensor on the tool head. So that's okay. So I mean, this really, people do get upset about this question. I don't know why. They just get upset. And there's two main groups in the ADXL location. One is toolhead. The toolhead board, like an EBB 36 or an stealth burner type toolhead board, 2-piece hard case style. The other is the nozzle. And the argument goes, you want the nozzle because you want to see where it's actually printing out of, which seems to make sense. And then the argument for the toolhead board, EBB 36 or stealth burner style, is you want as close to the center of mass as possible. And they both have their pros and cons. The con of a nozzle probe is a nozzle acts as a pendulum. So it's introducing a vibration that makes it difficult at times to figure out mechanical issues. And the negative of a toolhead board is it's not necessarily the center of mass, and the board itself can vibrate. The umbilical plays a role. It's usually hanging off the top back of the toolhead. So
right. But the result is, what is it you're trying to do, right? Because Clipper only cares about a single peak, right? It doesn't care, and you're where it's at per se. It's just going to cancel out whatever peak you give it. If you're looking for mechanical issues, most nozzle probes are hooked to a hot end that's a pendulum. I would say don't do it if you're looking for mechanical issues.
I think
Mechanical issues.
one of the things that you said earlier that I really agree with is, you pick a sensor, like if you got the cartographer or the EBB, you pick one and you run all the tests with that one. So it's not necessarily the location, which location is better. It's just the consistency of using the same location.
Right, and it's also what testing has been done at that location.
Yeah.
Right. So all if you go to I got a GitHub too with a bunch of this resident stuff in it. If you go there, 90% of the testing is done with the toolhead board.
Yeah.
Right. So if you throw a cartographer at me, or a beacon, or you throw the nozzle probe, the first thing I'm going to say is run it on toolhead board, because that's the data I have to be able to say what's the mechanical issue. Right. And I don't know anyone that's done an equivalent test with, or has equivalent data with any other form of ADXL location. And that's why I say it depends on what you're looking for, right? If you're just looking for the number at the toolhead, go ahead, run it. If you're looking for information on potential mechanical issues, right? Like what's wrong with my printer, I would say toolhead board, just because we have data there. We know what things are supposed to look like and not look like. I hope that helps. Mike, the slicer setting video is on
Is it in the Discord?
GitHub. On the Discord, thank you. On Discord.
Yep, it's in the Discord, Mike, and I will put the link to this video in the video description when we're done. Okay, so Cowbite did get back. He's got the stepper online. Looks like
those. I think those are what. So there's some moons and some stepper onlines.
Yeah. That
do not like the default PWM frequency.
So it looks like it's the.
He may be better at a lower PWM frequency.
Okay.
But that would require installing ShakeTune.
TMC Auto-Tune.
Thank you.
Yeah.
Thank you. Yeah.
I'm going to take a quick break to plug my headphones in because my earbuds are dying. So I apologize if we're going to... well, I'm not going to go anywhere. I'm just not going to talk. But I also have to figure out that without screwing up the audio again. Mike, you use 0.4. Are you talking about a nozzle or were you talking about pressure advance? Because that comment came up during the pressure advance section. So.
Yeah. What you doing, Mike? What you doing over there? I've actually started moving to a 0.5 nozzle. Basically I'm using 0.4 settings on a 0.5 nozzle. And the reason I'm doing it is just to get that little extra flow. So I can run it slightly faster than the 0.4.
Right now.
You guys hear me now?
You should be able to hear you now.
They should be able to hear me now. Sorry, guys, you lost the whole... It's actually all about the Holy Hand Grenade of Antioch. Not the Grail's a misnomer. You want the Holy Hand Grenade of Antioch.
So I think if I can hear you, they can hear you.
Yeah.
So I had to switch over to the Hadamames.
Calbyte, the PWM frequency, I don't know if you heard it, so I'm going to repeat it, is one of the variables in TMC Auto-Tune. It's got a list of variables, right? And you put it underneath each motor. So underneath each motor should be a voltage, 2448, whatever you're using. Then the next one down can be the PWM frequency. And I'm not sure the exact language, but it's in the just description of variables. And you want to try, I think it's 23E3 is what you want to type.
Up. Let me pull TMC Auto-Tune up. So, right here.
Yeah, right there. PWM _ frequency _ target. You want it to say, I think 20. I would start with 23E3, and then I would do it again. And this is going to be under each your X and Y motors. I would do it again with 20E3. See which one's better. And then obviously you can do it like at 45 and 55. Some motors just like a lower PWM frequency. It's not good or bad. It's just what it likes.
So, all right. Let's see something.
So many questions. All right, so we have a flow. One of the very first questions was, what order should you do all this crap in, right? There's so much crap. What should I do? I would say once you got your, let's just say you're building a V2 or a Trident, because that's what I know.
Yep.
Once you got your tool head set up, right? You got your umbilical set up, and you have the rear panel on. Not all the panels, just the rear panel. I would start running belts and tuning that. And then I would run input shaper, and I would use these two tests together to find mechanical issues. And there's a big old flow chart of how to do it here.
Yeah, actually, it's right here. I just
yeah.
See, can I?
You should be able to click it.
Can't click on it.
There's
right
What's
there.
this? Does it let you?
Oh, copy it. There we go.
There you go. I don't know if you can even read this. But this is a flow chart that Fricks and I and Andrew and others contributed to kind of figure it out. But basically, it's going to be a loop, right? So you're going to do belt shaper, input shaper till those look good, okay? Then you're going to run throw vibrations in it. Then you're going to take the results of those two tests, the acceleration from input shaper and the speed from vibrations profile, and you're going to run your PA test. And then you're going to run EM. And then you're going to say, run input shaper again, right? Because you got to kind of get the setup, those values in. So you get your initial PA, initial EM in. Then you run a cube, a Voron cube, or whatever you want to use to diagnose this kind of issues. And then you take a look at that and you make some mechanical adjustments if you see something bad, and you keep staying in this loop. And that's kind of how it goes.
And it's very easy to get carried away with this loop.
Oh yeah, 100%. 100%.
So don't get so caught up into going through the entire loop, or even going through the loop more than once. Just go go until you're comfortable with how your printer's performing and how the prints are coming out. So once you start getting prints that look great, and
stop.
and you're happy, like you get a print off and you're like, hell yeah, all that tuning worked out perfect. Stop.
Yeah.
Because you've gotten to a point where you're happy.
Diminishing returns.
Yes, exactly. It does get into diminishing returns, very, very quick. So, and you can put hours, if not days, if not weeks into this. So, like, seriously, don't do that.
I would say, Mike, don't aim for consistent. try to tune your printer to the prints that you like.
Yeah.
Because what you like what is good enough for you
Don't be David.
may not be good enough for me, right? And what's good enough for me may not be good enough for David.
Yeah.
So we all, if you view it as a quality print, now there's some standard things, right? Like you don't want gaping holes in your perimeter, right? Like there's some standard good enoughs that we can all agree on.
You don't want rounded corners.
Well, see, that might be a situation. I'm talking more like we see line separations.
Yeah.
You know, that's not. I mean, we're talking like, oh, there's a little bit of a wave here that's terrible, right?
Mm.
Like, once it's good enough that people are like, wow, this is 3D printed, you can stop.
Yeah. You could probably, and if it's not like a person who's into 3D printing, you probably could have stopped a little bit earlier than that too.
Yeah.
So,
yeah, I mean, it's how far you want to take it, and there is a diminishing return.
Yeah.
And don't. While this is all like fun to do, and for me it's fun to talk about and look at, you can get to a point where you're not even printing on your 3D printer.
No, you're just tuning it.
Just tuning it.
Yeah, that's and honestly, that's been me with this Blue NG. Like ever since I built it, it's literally just been. I think I've only printed. This is the only print that I've done on it that wasn't that wasn't a tuning print, and I did this yesterday. so it's like one of those things where it's like you can fall into that rabbit hole very easily. And that rabbit hole is very deep.
And I was helping someone once, and the reason this came about because I was very aggressive and it's got to be the best. And I ended up helping someone once, and it was so frustrating for them that they just kind of gave up. Right, they're like looking to sell their 3D printer, and I was like, okay, wait, this is not right.
Yeah,
maybe, but so these are supposed to be fun tools to print with, and you should be doing that.
And this is more on the lines of like advanced tuning too, like you can use your stock slicer profile, and then just tune your flow and pressure advance, and just kind of leave it at that, and still get good prints.
I would say go through this once. I would say at the bare minimum, go through it once, get the values, plug them in, and then you could be done.
Yeah.
Because this is all. It's basically going through it once is free performance.
Yeah.
It doesn't cost you anything to do it once, and then you get extra performance. You can print faster at a better speed.
Yeah. I'm like that too, Wix Central, but it's instead of every week, it's every day, and it's on my Blue NG. It's like, which test am I running on this NG today? Am I doing another vibration profile? Am I running the belts in Input Shaper today to see if it's better than it was yesterday? It's. But the thing is though, is that I don't do that on all of my printers, So I have this one dedicated, like, you can call it my speed test rig. So,
I have a test rig. It's not for speed, but
yeah. Well, that's what I built this one for. I built this one to see. I want to see how far I can push an NG. So, Mike.
So when do you recommend this loop? So a maintenance schedule. This loop. So this kind of input shaping vibrations should be done anytime you mess with the belts.
Yes.
If you mess with those belts, you've got to redo it. Like taking the tool head off and on, not necessary, right? If taking the tool head off does not require you to mess with the belts,
yes,
you can just put that tool head back on. But if you're replacing bearings or belts on your gantry, you should run it at least once.
Yep.
To see. Because I guarantee you your belts are going to be off.
I'd be surprised if it wasn't.
Right. Even if you do the what is it, armchair engineering, and they have it so that the belts stay there and you can kind of pull them. When you loosen a belt, like even taking them off of the armchairs, right, which are the Zoll, which you just put it in, you put a pin in.
You're still changing the tension.
you're still changing tension.
Yeah.
You're adjusting it from where it was.
Yeah.
So I would always run this whenever I mess with that stuff.
Yeah. Yeah. No, I agree.
Performance degradation, Mike. You will see it over time. You will as
Yeah, we just saw it on mine. We just saw it on mine.
Yeah. So you could get performance degradation from lube wearing out on your linear rails, because it does wear out. And then your balls start grinding.
Yeah, I hate when that happens.
You know, you got to put talcum powder or whatever on them. Take care of that. You know what I mean?
Yeah.
But
It's usually worse in the summer.
Yeah. Your belts can wear out. You could have a situation where your belts are slowly grinding on a flange of a bearing or pulley, and you'll see it. I mean, we all have belt dust everywhere. I think.
Wait, you do?
Um,
you should get that checked.
I should.
No, I got it everywhere.
But yeah, that's slowly wearing out your belts.
Yeah.
So there is a maintenance cycle involved, but no one really knows what it is. So
yeah, that's what we were talking about, Noda.
So sometimes it doesn't show up on your prints, right? Because let's take some linear rails, right? If you don't have just a crap, let's say you're using a West 3D or a KB3D or Fabrico, you know, one of those guys in their linear rails, those rails will keep going as long as you don't clean them, right? They'll be like, so for me, I use the wrong lube. I use the stuff with PTFE balls in it, right? That rail was going fine even with it, and it didn't really show up. I was just doing standard maintenance, taking things apart, and I noticed that the rails were pitted. But you don't get the consistency, I would say. So one print may print good because all the grime and dust help that section of the bearings to flow, and you know what I mean. Like sometimes the dirt helps.
It's kind of like your car when you run it for 100,000 miles and you don't change the transmission fluid, and now it's black and thick, and your gears and clutch packs and stuff like that are used to the thick oil, and you go and put new oil in, and now it starts to slip.
Yeah, that's fucked up. Yeah, it's the same thing. Like, and when it fails, when the parts here fail, they don't fail in a dramatic fashion.
Mm-hmm.
It's that print didn't come out, so you adjust your slicer, right? And then that one looks okay. And it's like a slow, like a frog being boiled in a pot of water, right? It doesn't know it's being boiled until it's dead. It's kind of the same thing with these failing printer parts.
I think what you could be able to see from your prints, though, is like if your belts were coming loose, if your belts were wearing, if you had
belts, you can see.
Yeah, like so if you're starting to see some questionable things in your prints like that, then yeah, it wouldn't hurt to go through and just use these tools as a diagnostics tool, like we were saying, like I just ran my input shaper and now I have that weird spike. So I'm gonna go check my bolts and run it again until I get that nice smooth graph again, and then I'll go through the cycle again to get it back to where it was.
And if you run these tests, I mean, I'm not saying don't run these tests, but if you run these tests enough, you know your printer enough.
Yeah.
You know what you can get away with. Right, so like none of my printers right now would qualify or even as good as David's here. They're not. But for what I print, which is mainly flexi toys, right, for kids, it's good enough. So I'm not going to spend 2 or 3 days tracking down the problem, fixing it. Right, I'm just going to print my flexis because it's good enough for what I print.
I think that would be a good segue for you to talk about your 3D printer L's.
Oh, you wanna pull it up?
Yeah.
Have a nice pretty.
Yeah, because I think that's super cool that what you guys do.
So, my wife and I. So I got into 3D printers, right? And I started printing all the things I like to print, right? And then became, what do I print? Right? I'm kind of out of things that I wanted to print, and I had these printers. I wanted to, just have them keep going. So my wife volunteered me to print about 160 Slinky rabbits for Chinese New Year for all of 2nd grade in my son's school. And we donated those off. And then we found IC3D, and they do Toys for Tots. But they only did Christmas time. And where I live is the Central Valley of California. A lot of poor, farm schools and kids. So then we decided to basically just print all year round. So last year, I think you went up top. I think I put the numbers up top.
Yep, 3,700.
Yep. So last year we gave out 5,300 toys. It was basically all the places with CASA, which is Quarter Point Special Advocates, which is foster youth. The family court we gave them because kids go there, and then a whole bunch of elementary schools, cerebral palsy. This year so far we've given out 3,700 toys. Some of these schools are like rural, so basically we just started printing toys. We created our own nonprofit, and this is what we do. So I just want to talk about that. And then if you go to the very bottom, I think my wife. Oh, those are all the people that donated to us. Micro Center, LDO. LDO's been great.
LDO's a great.
And West 3D.
Yeah. These are all great companies.
Yeah, everyone there has donated. Cartographer, Vitali. I mean, great companies, great guys. Very, very giving to our community as a whole.
Yeah.
But if you scroll all the way down, my wife created a group right there, the Voron Widows. And if you get a chance, take a look at it. Have your wife or spouse or boyfriend, whatever your significant other is, take a look at it and hopefully get a good laugh. And
should I click on it?
No, leave it a surprise for everyone. Let them all look. But so if you're on the Voron Discord and you are a spouse or partner or whatever of a person that owns a Voron, reach out to the Voron Widow, and they have a special channel that people can't enter except for the spouses, and you guys can, I don't even know what they do. I don't even have access to it. My wife doesn't even tell me. But it's just something fun we did because she's like, she's a widow because I donate all my time to 3D printing. But yeah, so this is our nonprofit. Unfortunately, we can only do, because we're very small, right? We're not a major nonprofit. The elves, you can send us toys, but we can't send you filament in exchange because we just don't have the funds to do it. We do a filament exchange. You give us, a filament's worth of toys. We give you a filament or 2 filaments back in return.
Now, this is just my thoughts. This isn't anything official, so don't quote me on it, but I'm sure there is a filament company out there that if you reached out to them, they would probably be willing to help you if you told them what it was for.
Well, I would like to take another opportunity to thank Micro Center, because Micro Center went above and beyond when we met them at Rocky Mountain last year, and they went above and beyond with a huge donation of filament.
Yeah.
And we don't want to be. We have plenty of certain kinds of filament like PLA and silkweed, and LDO has contributed ABS filament.
Their ABS is awesome.
Yeah, it's great, and we're actually give a whole bunch of it. Like probably half the filament they give us is going to go to the local community college.
Yeah.
They're have an engineering group, and they do underwater rover competitions.
That's really cool.
Yeah, they've got to design it and everything, and then they print out all the parts. So we've been helping them, giving them filament because everyone needs a little help. So that's what we do.
I know the LDO filament can be purchased from Fabrico. I think they're the only ones, right?
Only ones Fabrico.
And then And West
Ambrosia.
And West 3D has Ambrosia, and that's really good. Ambrosia's really good stuff. They also have Protopasta too. That stuff's a little pricier.
I've never used Protopasta.
I've never used it either. It's
a little pricey for me.
Yeah, it's too rich for my blood, but the Ambrosia's good stuff.
Yeah. But I will say Jason has been extremely kind. Like LDO in general and Jason.
Jason's a saint.
I got nothing but good words. I mean,
Jason is a saint.
Yes.
So all these guys, they just, you know.
Yeah.
They
Fabrico, Hector too. I mean, that guy.
Dan at West 3D, yeah.
Yeah. Those guys are great.
Mm-hmm.
So we all my printers that I do, they're all, what I got right now, 4 running right now, and they're nonstop, 24/7.
Yeah, that's awesome.
Since we've been doing this, but yeah.
Shit.
Thank you for letting me speak about my nonprofit.
Of course, man. So I think I'm out of questions on all this. I think even though
you'll have tomorrow, you're like, I should have asked that.
even though we've gone over this quite a bit on the side, I think even for me, you know, this past 3-hour conversation has been helpful for me. So hopefully everyone
Can I add one more thing?
Of course, yeah.
So if you guys need help, the Voron channel, it's a general chat channel, has a resonance section. I think it's called Resonance Basic Help. We can help with Vorons. We can also potentially help with non-Vorons. But my knowledge and the knowledge of Spitz and others is not, because it's a different printer, it has different characteristics. But we can potentially help you if you're like just at your wit's end and you just need some help to get it going or figuring out where to even start looking to help you do it. And that would, you just open a thread and I know Spitz will probably get mad at me, but I don't mind. I know what it is not to know about this stuff, and I don't know about all the printers, but we can try to help you if you need that help, if you're stuck on what to do, or if you need help on auto tune or something like that.
And I'll add to that because I've been there. I only have the only Voron I have is a switch wire, and honestly I don't have any issues with it. So and it's a switch wire, so I'm not pushing through ShakeTune. I'm not.
You can. It'll run on it.
Yeah. No. So I do have ShakeTune installed in it. I have ShakeTune installed on all of my printers, but I don't push through it as much as I do with my other printers. But
Fair.
But you know, I've gone to the Voron Discord for help with my NG, and you know, and on more than one equation, I've gone there for my Mercury 1. So you know, they will try to help you. They might not be able to help you to the point that you might be thinking you would get the level of help, and that's not.
It's a lot less.
It's not because they don't want to. It's just because they're not familiar with your printer. So just keep that in mind. And then, you know, you do have my Discord too, where you know there's intelligent people there as well, who can help you with this, and you know, Reth is in the Discord as well, and yeah, I mean, you got a bunch of other people in there too. So just don't be afraid to reach out for help with this stuff, because it is not easy to understand the first time you're looking at it, the second time you're looking at it, the 15th time you're looking at it. There's a big learning curve to it. So like I've been using this for, I mean, I've been using it for a while. I haven't been understanding it for a while, but I've been using it for a while, and I'm learning more and more about it every day, to the point where I can actually start to implement the stuff that I'm getting from it into Slicer. So into the Slicer, and actually seeing it in the prints versus, you know, running Input Shaper and then just putting the MZV and the Hertz and the config and saying that I did Input Shaper and just printing at whatever speed I feel like.
It does take a while, and a lot of, you're right. Everything you said is correct. I was just writing to Havoc and Mike, and if you guys bring non-Voron printers into the Voron Discord for input shaping, just make sure to ping me in it. I may be working, not answer right away, but just make sure you ping me.
And make sure you put down as much information about your printer as possible.
Yeah, I mean, yeah.
Does anybody else have any other questions for us before I do the giveaway? Any other questions? Oh, actually, I want to point out one more thing real quick. So we talked about my graph here. Right here, we have this peak right here and this peak right here, and we're talking about the excite frequency. And so basically what you do is you would drop down from the point, you know, pick that, what did we say this was, 63? You said this one was 63, yeah, right? 63. So we would go over here to the dashboard, and don't just click on this, go to the drop down menu of it, and I can't tell. Can you see the drop down?
I can see the drop down.
Okay.
You might need to move chat over.
Oh yeah, chat's covering it. So, and this is just a quick overview of it. I'm not going to run the test right now because I'm not over there to listen. But you want to pick your duration, you know, whether it's, you know, 30, 60, 90 seconds, however much time you think you need to investigate your printer.
45, 60 is probably a good.
Yeah. I usually do 45. I usually do 45 because it honestly
30 is too short. 30 is way too short.
And 45, it's enough time to poke your head around the printer and find what you need. You pick your access and your frequency, and then you send it.
That's all you really need to set.
Yeah. You just need your duration, access, and frequency, and you're gonna just match the access and frequency up with the issue that you're having. That oddity in your graph, you'll just match it up with that. So,
and then you should have the graph. Did you run it?
I didn't run. You know what? Screw it. This was at Y on Y, and this was
it's a 45-second test.
Yeah, 45, and then 63.
Number
4,500 what?
Oh, instead of 45 seconds, 4,500 seconds, I think he means.
Oh yeah, no, dude, don't do 4,500 seconds. Yeah, it'll be shaking for a while.
You have to hit the E-stop button.
Yeah.
And then once it's done, it should be, you know. But yeah, so anybody have any other questions? I know there's a lot of information.
It is a lot to digest.
It is a lot, I know. And there's nuances in this.
I would recommend against that Central.
Oh my God, no.
Although if you do send it on 45 seconds, just record it. Record it and upload it. I'd watch that. All right, so you said that's going to go under static frequency.
Is it there? There should be a graph. Oh, you know why? I don't think you hit the button on it. Did it output disable excitation? Yeah, so in the ShakeTune thing, I think there's a. Try it again. Try the refresh on this one.
You mean like in this drop down right here?
No. Let me look. I think it's a. Is it in the folder again?
No.
No. So ShakeTune.
Is it? Is there something in my printer CFG?
No, it'd be the ShakeTune section, I think. Max frequency. Show macros. True number. No, it should be. Oh, let's see, because it should be generating a picture. Excite at frequency. Is there any other folders there?
Yeah,
Oh, create graph. It's a default value. It's create graph is 0. So it's when you run the test. Create graph needs to be a 1.
Oh, 1 here. All right.
Yeah, just run it for like 10 seconds because it's just, you don't need the full thing on it. Just to kind of get a visual of what it means. It should be pretty quick. So that's one quirk of that test is if you want to see the graphs, you have to enable that.
Change it to a 1. Yeah, absolutely, Wix Central. And Mike and Joe, I'm glad this was helpful. You know, it was something that I thought about. Was it last week when we talked? It was after I put 48 volts on this printer, and we
48 volts will change.
And we talked about this, and I was like, I think we need to share this with other people. So,
so this is showing you there's a couple ways to use this test, right? One way is just to run it without the graph and start putting your finger places and kind of seeing it that damping it, right? It's going to dampen it because you have your finger on it, but you're kind of touch it and prod and see if you can figure out a problem. The other way is to run it with the graph like this, and you'll get the primary peak at 63, then you get its harmonics, right? Mm-hmm. Which is the other two ones. And then you get these vibrations on the right, which is time and the energy. And if you got something vibrating there, it depending upon the time, it may vibrate at different times. So maybe it's not vibrating right away. It takes a little bit to get going.
Okay.
You can use this, and then you can like maybe touch it for 10 seconds and then run it. And while you're touching it, right? And then you'll see what your finger has an effect. It's similar to what Rados does with their live ADXL,
mm-hmm.
but this one's not live, right? It's giving the data after the fact.
Okay.
So there's different ways to use the graphs themselves. I personally haven't found them very useful. I do find the tests useful, but the graphs, not so much.
Yeah. Okay. Yeah, I've actually never used the graphs before. I've always just ran it for about 45 seconds or so and just kind of poked around and kind of tried to touch things to see when the vibration would stop. So usually I end up finding like a rattle, or it's like a loose bolt or something's touching it. The only thing I'm not sure would affect it is so on this printer, the X end stop, the micro switch is on the tool head itself. So I don't know if the lever.
No, lever's way too lightweight.
Yeah, I was gonna say I don't think that's enough to.
Now cables being if you're not very good at wire management like me.
Oh no, I'm
really big.
You can ask chat. I'm amazing at wire management. You can ask chat. Yeah, they'll let you know how fantastic I am. And
well, I mean, I'm not as fantastic as you. So cables themselves out in the breeze will cause things to vibrate.
Yeah.
How much is an effect? I don't know. The test will pull it up though.
True.
Wiki, there is no way to get a live result like Rados does for excite at frequency.
You can see Mike's comment and Dan, the best.
See?
Yeah. See. My people know me.
They know you're the best. No wire shaming.
All right.
Yeah, so that's what I got for now. Unless you got more questions, or chat has more questions.
So on that note, while chat is or is not adding any of their additional questions, let's do this. It's 10:31 here. We've had the giveaway link open up for a while, so I am going to close it. So if you have not filled out the giveaway link, which is the pinned comment in the top, you have 30 seconds to do so. And then I'm closing it. So yeah, there's that. US only, by the way.
I didn't enter.
So enter.
I know.
You're entitled to enter. I think I'm the only one here not able to enter. Oh wait, no. Shut, Martin. You can't enter because you just won. Who else? I don't know. You know who you are. If you won in May, you can't enter. If you won in May, you can't enter. Yeah, that's my. If you win, you have to wait till the next month to enter again because I don't have that. I don't have a big enough audience, so I want to make sure everyone gets a chance. Because I've already had some repeat winners, so.
Oh, they should return the filament.
Nah.
That would be the honorable thing to do.
Well, not repeat in the same month, so. Plus, and then I don't want Atomic being like, these are the same people winning. They have to
unprint their prints and return all the filament.
Atomic seems fair. Atomic be like, are you just having your friends win? Like, they're all my friends.
You know, you always hear everyone's thing is like, oh, it's rigged. It's rigged.
Oh yeah, is Django here? Why is this giving me crap? Great. Did Django already start talking about how it's rigged?
Thunder Keys? No, it's only rigged Thunder Keys when you win. Only when you win do we know it's rigged. Does Django, what have you won 5 times already?
He has not won ever. He's never won.
You've never won Django.
And I'm pretty sure he doesn't even put his name in there anymore. He just says it's rigged. That's what he put. That's what he put. That's what he puts his name down.
You've discouraged him so much. Why should he put his name in?
I mean, I think. Also, if you look at him in the Discord, he has the very rare role of conspiracy theorist.
It's not a conspiracy if it's true. I'm with you, Django. I'm in your court, at least for now. Is Thunder Keys in there? Because we need to pull him out.
Is Thunder Keys in here? Yep, there he is right there.
Oh.
Right, so
Django, I think you might be right.
Where's he? I don't even see Django's name in here. Oh, there it is.
Oh, yeah.
Oh, shoot. I hit spin. All right, well, there we go. Robot Overlord.
All hail our robot overlords.
Robot Overlord.
Congratulations,
You won on the accidental click, so congratulations.
Sorry, Django. I think you're right.
Now, this time Django was on the opposite side of the board, so he didn't stand a chance. That was the surprise click. Why, did you just win it? Did you win somewhere else, Robot? All right, Robot, send me a message on Discord with your atomic choice. I guess some phone calls to make with Atomic. So, congratulations, Robot.
Congratulations, sir.
And to everybody that joined tonight, thank you again. And if you're able to, check out 3D Printing Elves and give Reth a hand. Reth and his wife a hand with that. And subscribe to his channel. So.
Thank you.
Yeah.
It was a pleasure, sir. It was a pleasure doing this.
Pleasure was mine.
Had a lot of fun.
So.
Had a lot of fun.
So I appreciate it. And yeah, thank you again, everybody. If you were too shy to ask your question live in chat, you can send it to either one of us. So on that note, good night, everybody. And I will see you on the next one. I'll probably be back to my regular schedule next week. So probably back to Tuesday next week if I can figure out something
You're
to
welcome,
do.
Guys. You're welcome.
So absolutely. Everyone have a good night.